OSHA 1926 Subpart M, Fall Protection. 1926.500, Scope, Application, and Definitions applicable to this subpart. 1926.500, A, Scope and Application. 1926.500, A1, this subpart sets forth requirements and criteria for fall protection in construction workplaces covered under 29 CFR Part 1926. Exception: the provisions of this subpart do not apply when employees are making an inspection, investigation, or assessment of workplace conditions prior to the actual start of construction work or after all construction work has been completed. 1926.500, A2, Section 1926.501 sets forth those workplaces, conditions, operations, and circumstances for which fall protection shall be provided except as follows. 1926.500, A2I, requirements relating to fall protection for employees working on scaffolds are provided in Subpart L of this part. 1926.500, A2, the second, requirements relating to fall protection for employees working on cranes and derricks are provided in Subpart CC of this part. 1926.500, A2, 3, fall protection requirements for employees performing steel erection work, except for towers and tanks, are provided in Subpart R of this part. 1926.500, A2, 4, requirements relating to fall protection for employees working on certain types of equipment used in tunneling operations are provided in Subpart S of this part. 1926.500, A2, V, requirements relating to fall protection for employees engaged in the erection of tanks and communication and broadcast towers are provided in Section 1926.105. 1926.500, A2, 6. Subpart V of this part provides requirements relating to fall protection for employees working from aerial lifts or on poles, towers, or similar structures while engaged in the construction of electric transmission or distribution lines or equipment. 1926.500, A2, 7, requirements relating to fall protection for employees working on stairways and ladders are provided in Subpart X of this part. 1926.500, A3, Section 1926.502 sets forth the requirements for the installation, construction, and proper use of fall protection required by Part 1926, except as follows. 1926.500, A3I, performance requirements for guardrail systems used on scaffolds and performance requirements for falling object protection used on scaffolds are provided in Subpart L of this part. 1926.500, A3-2, performance requirements for stairways, stair rail systems, and handrails are provided in Subpart X of this part. 1926.500, A3-3, additional performance requirements for fall arrest and work positioning equipment are provided in Subpart V of this part. 1926.500, A3-4, Section 1926.502 does not apply to the erection of tanks and communication and broadcast towers. Note, Section 1926.104 sets the criteria for body belts, lanyards and lifelines used for fall protection during tank and communication and broadcast tower erection. Paragraphs B, C, and F of Section 1926.107 provide definitions for the pertinent terms. 1926.500, A3V, criteria for steps, handholds, ladders, and guardrail/railings required by Subpart CC are provided in Subpart CC. Sections 1926.502, A, C, through E, and I apply to activities covered under Subpart CC unless otherwise stated in Subpart CC. No other paragraphs of Section 1926.502 apply to Subpart CC. 1926.500, A4, Section 1926.503 sets forth requirements for training in the installation and use of fall protection systems, except in relation to steel erection activities and the use of equipment covered by Subpart CC. 1926.500, B, definitions. Anchorage means a secure point of attachment for lifelines, lanyards, or deceleration devices. Body belt, safety belt, means a strap with means both for securing it about the waist and for attaching it to a lanyard, lifeline, or deceleration device. Body harness means straps which may be secured about the employee in a manner that will distribute the fall arrest forces over at least the thighs, pelvis, waist, chest, and shoulders with means for attaching it to other components of a personal fall arrest system. Buckle means any device for holding the body belt or body harness closed around the employee's body. Connector means a device which is used to couple, connect parts of the personal fall arrest system and positioning device systems together. It may be an independent component of the system, such as a carabiner, or it may be an integral component of part of the system, such as a buckle or D-ring sewn into a body belt or body harness, or a snap hook spliced or sewn to a lanyard or self-retracting lanyard. Controlled Access Zone, CAZ, means an area in which certain work, e.g., overhand bricklaying, may take place without the use of guardrail systems, personal fall arrest systems, or safety net systems, and access to the zone is controlled. Dangerous equipment means equipment such as pickling or galvanizing tanks, degreasing units, machinery, electrical equipment, and other units, which, as a result of form or function, may be hazardous to employees who fall onto or into such equipment. Deceleration device means any mechanism, such as a rope grab, ripstitch lanyard, specially woven lanyard, tearing or deforming lanyards, automatic self-retracting lifelines/lanyards, etc., which serves to dissipate a substantial amount of energy during a fall arrest, or otherwise limit the energy imposed on an employee during fall arrest. Deceleration distance means the additional vertical distance a falling employee travels, excluding lifeline elongation and free fall distance, before stopping, from the point at which the deceleration device begins to operate. It is measured as the distance between the location of an employee's body belt or body harness attachment point at the moment of activation, at the onset of fall arrest forces of the deceleration device during a fall, and the location of that attachment point after the employee comes to a full stop. Equivalent means alternative designs, materials, or methods to protect against a hazard which the employer can demonstrate will provide an equal or greater degree of safety for employees than the methods, materials, or designs specified in the standard. Failure means load refusal, breakage, or separation of component parts. Load refusal is the point where the ultimate strength is exceeded. Free fall means the act of falling before a personal fall arrest system begins to apply force to arrest the fall. Free fall distance means the vertical displacement of the fall arrest attachment point on the employee's body belt or body harness between onset of the fall and just before the system begins to apply force to arrest the fall. This distance excludes deceleration distance and lifeline/lanyard elongation, but includes any deceleration device slide distance or self-retracting lifeline/lanyard extension before they operate and fall arrest forces occur. Guardrail system means a barrier erected to prevent employees from falling to lower levels. Hole means a gap or void 2 inches, 5.1 centimeters, or more in its least dimension in a floor, roof, or other walking/working surface. Infeasible means that it is impossible to perform the construction work using a conventional fall protection system, i.e., guardrail system, safety net system, or personal fall arrest system, or that it is technologically impossible to use any one of these systems to provide fall protection. Lanyard means a flexible line of rope, wire rope, or strap which generally has a connector at each end for connecting the body belt or body harness to a deceleration device, lifeline, or anchorage. Leading edge means the edge of a floor, roof, or formwork for a floor or other walking/working surface, such as the deck, which changes location as additional floor, roof, decking, or formwork sections are placed, formed, or constructed. A leading edge is considered to be an unprotected side and edge during periods when it is not actively and continuously under construction. Lifeline means a component consisting of a flexible line for connection to an anchorage at one end to hang vertically, vertical lifeline, or for connection to anchorages at both ends to stretch horizontally, horizontal lifeline, and which serves as a means for connecting other components of a personal fall arrest system to the anchorage. Low slope roof means a roof having a slope less than or equal to 4 in 12, vertical to horizontal. Lower levels means those areas or surfaces to which an employee can fall. Such areas or surfaces include, but are not limited to, ground levels, floors, platforms, ramps, runways, excavations, pits, tanks, material, water, equipment, structures, or portions thereof. Mechanical equipment means all motor or human-propelled wheeled equipment used for roofing work, except wheelbarrows and mop carts. Opening means a gap or void 30 inches 76 centimeters, or more high and 18 inches 48 centimeters, or more wide, in a wall or partition, through which employees can fall to a lower level. Overhand bricklaying and related work means the process of laying bricks and masonry units such that the surface of the wall to be jointed is on the opposite side of the wall from the mason, requiring the mason to lean over the wall to complete the work. Related work includes mason tending and electrical installation incorporated into the brick wall during the overhand bricklaying process. Personal fall arrest system means a system used to arrest an employee in a fall from a working level. It consists of an anchorage, connectors, a body belt or body harness, and may include a lanyard, deceleration device, lifeline, or suitable combinations of these. As of January 1, 1998, the use of a body belt for fall arrest is prohibited. Positioning device system means a body belt or body harness system rigged to allow an employee to be supported on an elevated vertical surface, such as a wall, and work with both hands free while leaning. Rope grab means a deceleration device which travels on a lifeline and automatically, by friction, engages the lifeline and locks so as to arrest the fall of an employee. A rope grab usually employs the principle of inertial locking, cam/level locking, or both. Roof means the exterior surface on the top of a building. This does not include floors or formwork which, because a building has not been completed, temporarily become the top surface of a building. Roofing work means the hoisting, storage, application, and removal of roofing materials and equipment, including related insulation, sheet metal, and vapor barrier work, but not including the construction of the roof deck. Safety monitoring system means a safety system in which a competent person is responsible for recognizing and warning employees of fall hazards. Self-retracting lifeline/lanyard means a deceleration device containing a drum wound line which can be slowly extracted from, or retracted onto, the drum under slight tension during normal employee movement, and which, after onset of a fall, automatically locks the drum and arrests the fall. Snap hook means a connector comprised of a hook-shaped member with a normally closed keeper, or similar arrangement, which may be opened to permit the hook to receive an object and, when released, automatically closes to retain the object. Snap hooks are generally one of two types. 1926.500 B1, the locking type with a self-closing, self-locking keeper which remains closed and locked until unlocked and pressed open for connection or disconnection, or 1926.500 B2, the non-locking type with a self-closing keeper which remains closed until pressed open for connection or disconnection. As of January 1, 1998, the use of a non-locking snap hook as part of personal fall arrest systems and positioning device systems is prohibited. Steep roof means a roof having a slope greater than 4 in 12, vertical to horizontal. Toe board means a low protective barrier that will prevent the fall of materials and equipment to lower levels and provide protection from falls for personnel. Unprotected sides and edges means any side or edge, except at entrances to points of access, of a walking/working surface, e.g. floor, roof, ramp, or runway where there is no wall or guardrail system at least 39 inches, 1 meter high. Walking/working surface means any surface, whether horizontal or vertical, on which an employee walks or works, including, but not limited to, floors, roofs, ramps, bridges, runways, formwork and concrete reinforcing steel but not including ladders, vehicles, or trailers, on which employees must be located in order to perform their job duties. Warning line system means a barrier erected on a roof to warn employees that they are approaching an unprotected roof side or edge, and which designates an area in which roofing work may take place without the use of guardrail, body belt, or safety net systems to protect employees in the area. Work area means that portion of a walking/working surface where job duties are being performed. 1926.501 Duty to have fall protection. 1926.501 A. General. 1926.501 A1. This section sets forth requirements for employers to provide fall protection systems. All fall protection required by this section shall conform to the criteria set forth in 1926.502 of the Subpart. 1926.501 A2 The employer shall determine if the walking/working surfaces on which its employees are to work have the strength and structural integrity to support employees safely. Employees shall be allowed to work on those surfaces only when the surfaces have the requisite strength and structural integrity. 1926.501b. 1926.501b1. Unprotected sides and edges. Each employee on a walking/working surface, horizontal and vertical surface, with an unprotected side or edge which is 6 feet (1.8 meters) or more above a lower level shall be protected from falling by the use of guardrail systems, safety net systems, or personal fall arrest systems. 1926.501b2. Leading edges. 1926.501b2. Each employee who is constructing a leading edge 6 feet (1.8 meters) or more above lower levels shall be protected from falling by guardrail systems, safety net systems, or personal fall arrest systems. Exception: when the employer can demonstrate that it is infeasible or creates a greater hazard to use these systems, the employer shall develop and implement a fall protection plan which meets the requirements of paragraph K of 1926.502. Note: there is a presumption that it is feasible and will not create a greater hazard to implement at least one of the above-listed fall protection systems. Accordingly, the employer has the burden of establishing that it is appropriate to implement a fall protection plan which complies with 1926.502 K for a particular workplace situation, in lieu of implementing any of those systems. 1926.501 B2. Each employee on a walking/working surface 6 feet (1.8 meters) or more above a lower level where leading edges are under construction, but who is not engaged in the leading edge work, shall be protected from falling by a guardrail system, safety net system, or personal fall arrest system. If a guardrail system is chosen to provide the fall protection, and a controlled access zone has already been established for leading edge work, the control line may be used in lieu of a guardrail along the edge that parallels the leading edge. 1926.501 B3. Hoist areas. Each employee in a hoist area shall be protected from falling 6 feet (1.8 meters) or more to lower levels by guardrail systems or personal fall arrest systems. If guardrail systems, or chain, gate, or guardrail, or portions thereof, are removed to facilitate the hoisting operation, e.g., during landing of materials, and an employee must lean through the access opening or out over the edge of the access opening to receive or guide equipment and materials, for example, that employee shall be protected from fall hazards by a personal fall arrest system. 1926.501 B4. Holes. 1926.501 B4 I. Each employee on walking/working surfaces shall be protected from falling through holes, including skylights, more than 6 feet (1.8 meters) above lower levels, by personal fall arrest systems, covers, or guardrail systems erected around such holes. 1926.501 B4 2. Each employee on a walking/working surface shall be protected from tripping in or stepping into or through holes, including skylights, by covers. 1926.501 B4 3. Each employee on a walking/working surface shall be protected from objects falling through holes, including skylights, by covers. 1926.501 B5. Formwork and reinforcing steel. Each employee on the face of formwork or reinforcing steel shall be protected from falling 6 feet (1.8 meters) or more to lower levels by personal fall arrest systems, safety net systems, or positioning device systems. 1926.501 B6. Ramps, runways, and other walkways. Each employee on ramps, runways, and other walkways shall be protected from falling 6 feet (1.8 meters) or more to lower levels by guardrail systems. 1926.501 B7. Excavations. 1926.501 B7 I. Each employee at the edge of an excavation 6 feet (1.8 meters) or more in depth shall be protected from falling by guardrail systems, fences, or barricades when the excavations are not readily seen because of plant growth or other visual barrier. 1926.501 B7 2. Each employee at the edge of a well, pit, shaft, and similar excavation 6 feet (1.8 meters) or more in depth shall be protected from falling by guardrail systems, fences, barricades, or covers. 1926.501 B8. Dangerous equipment. 1926.501(b)(8)(I). Each employee less than 6 feet (1.8 meters) above dangerous equipment shall be protected from falling into or onto the dangerous equipment by guardrail systems or by equipment guards. 1926.501(b)(8)(2). Each employee 6 feet (1.8 meters) or more above dangerous equipment shall be protected from fall hazards by guardrail systems, personal fall arrest systems, or safety net systems. 1926.501(b)(9). Overhand bricklaying and related work. 1926.501(b)(9)(I). Except as otherwise provided in paragraph B of this section, each employee performing overhand bricklaying and related work 6 feet (1.8 meters) or more above lower levels shall be protected from falling by guardrail systems, safety net systems, personal fall arrest systems, or shall work in a controlled access zone. 1926.501(b)(9)(2). Each employee reaching more than 10 inches (25 centimeters) below the level of the walking/working surface on which they are working shall be protected from falling by a guardrail system, safety net system, or personal fall arrest system. Note: bricklaying operations performed on scaffolds are regulated by Subpart L scaffolds of this part. 1926.501(b)(10). Roofing work on low-slope roofs. Except as otherwise provided in paragraph B of this section, each employee engaged in roofing activities on low-slope roofs, with unprotected sides and edges 6 feet (1.8 meters) or more above lower levels shall be protected from falling by guardrail systems, safety net systems, personal fall arrest systems, or a combination of warning line system and guardrail system, warning line system and safety net system, or warning line system and personal fall arrest system, or warning line system and safety monitoring system. Or, on roofs 50 feet (15.25 meters) or less in width, see Appendix A to Subpart M of this part, the use of a safety monitoring system alone, i.e. without the warning line system, is permitted. 1926.501(b)(11). Steep roofs. Each employee on a steep roof with unprotected sides and edges 6 feet (1.8 meters) or more above lower levels shall be protected from falling by guardrail systems with toe boards, safety net systems, or personal fall arrest systems. 1926.501(b)(12). Precast concrete erection. Each employee engaged in the erection of precast concrete members, including, but not limited to the erection of wall panels, columns, beams, and floor and roof tees, and related operations such as grouting of precast concrete members, who is 6 feet (1.8 meters) or more above lower levels shall be protected from falling by guardrail systems, safety net systems, or personal fall arrest systems, unless another provision in paragraph B of this section provides for an alternative fall protection measure. Exception: when the employer can demonstrate that it is infeasible or creates a greater hazard to use these systems, the employer shall develop and implement a fall protection plan which meets the requirements of paragraph K of 1926.502. Note: there is a presumption that it is feasible and will not create a greater hazard to implement at least one of the above listed fall protection systems. Accordingly, the employer has the burden of establishing that it is appropriate to implement a fall protection plan which complies with 1926.502 K for a particular workplace situation, in lieu of implementing any of those systems. 1926.501(b)(13). Residential construction. Each employee engaged in residential construction activities 6 feet (1.8 meters) or more above lower levels shall be protected by guardrail systems, safety net system, or personal fall arrest system unless another provision in paragraph B of this section provides for an alternative fall protection measure. Exception: when the employer can demonstrate that it is infeasible or creates a greater hazard to use these systems, the employer shall develop and implement a fall protection plan which meets the requirements of paragraph K of 1926.502. Note: there is a presumption that it is feasible and will not create a greater hazard to implement at least one of the above listed fall protection systems. Accordingly, the employer has the burden of establishing that it is appropriate to implement a fall protection plan which complies with 1926.502 K for a particular workplace situation, in lieu of implementing any of those systems. 1926.501(b)(14). Wall openings. Each employee working on, at, above, or near wall openings, including those with chutes attached, where the outside bottom edge of the wall opening is 6 feet (1.8 meters) or more above lower levels and the inside bottom edge of the wall opening is less than 39 inches (1 meter) above the walking/working surface, shall be protected from falling by the use of a guardrail system, a safety net system, or a personal fall arrest system. 1926.501, b. 15. Walking/working surfaces not otherwise addressed. Except as provided in 1926.500, a. 2, or in 1926.501, b. 1, through, b. 14, each employee on a walking/working surface 6 feet (1.8 meters) or more above lower levels shall be protected from falling by a guardrail system, safety net system, or personal fall arrest system. 1926.501, c. Protection from falling objects. When an employee is exposed to falling objects, the employer shall have each employee wear a hard hat and shall implement one of the following measures. 1926.501, c.1. Erect toe boards, screens, or guardrail systems to prevent objects from falling from higher levels, or 1926.501, c.2. Erect a canopy structure and keep potential fall objects far enough from the edge of the higher level so that those objects would not go over the edge if they were accidentally displaced, or 1926.501, c.3. Barricade the area to which objects could fall, prohibit employees from entering the barricaded area, and keep objects that may fall far enough away from the edge of a higher level so that those objects would not go over the edge if they were accidentally displaced. 1926.502. Fall Protection Systems Criteria and Practices. 1926.502, a. General. 1926.502, a.1. Fall protection systems required by this part shall comply with the applicable provisions of this section. 1926.502, a.2. Employers shall provide and install all fall protection systems required by this subpart for an employee, and shall comply with all other pertinent requirements of this subpart before that employee begins the work that necessitates the fall protection. 1926.502, b. Guardrail systems. Guardrail systems and their use shall comply with the following provisions. 1926.502, b.1. Top edge height of top rails, or equivalent guardrail system members, shall be 42 inches, 1.1 meters, plus or minus 3 inches, 8 centimeters above the walking/working level. When conditions warrant, the height of the top edge may exceed the 45-inch height, provided the guardrail system meets all other criteria of this paragraph. Note: when employees are using stilts, the top edge height of the top rail, or equivalent member, shall be increased in amount equal to the height of the stilts. 1926.502, b.2. Mid-rails, screens, mesh, intermediate vertical members, or equivalent intermediate structural members shall be installed between the top edge of the guardrail system and the walking/working surface when there is no wall or parapet wall at least 21 inches, 53 centimeters high. 1926.502, b.2, I, through 1926.502, b.2, 4, mid-rails, when used, shall be installed at a height midway between the top edge of the guardrail system and the walking/working level. Screens and mesh, when used, shall extend from the top rail to the walking/working level and along the entire opening between top rail supports. Intermediate members, such as balusters, when used between posts, shall be not more than 19 inches, 48 centimeters apart. Other structural members, such as additional mid-rails and architectural panels, shall be installed such that there are no openings in the guardrail system that are more than 19 inches, 0.5 m, wide. 1926.502, b.3. Guardrail systems shall be capable of withstanding, without failure, a force of at least 200 pounds, 890 newtons, applied within 2 inches, 5.1 centimeters of the top edge, in any outward or downward direction, at any point along the top edge. 1926.502, b.4. When the 200-pound, 890 newtons, test load specified in paragraph b.3 of this section is applied in a downward direction, the top edge of the guardrail shall not deflect to a height less than 39 inches, 1 meter, above the walking/working level. Guardrail system components selected and constructed in accordance with the Appendix B to Subpart M of this part will be deemed to meet this requirement. 1926.502(b)(5), midrails, screens, mesh, intermediate vertical members, solid panels, and equivalent structural members shall be capable of withstanding, without failure, a force of at least 150 pounds, 666 newtons, applied in any downward or outward direction at any point along the midrail or other member. 1926.502(b)(6), guardrail systems shall be so surfaced as to prevent injury to an employee from punctures or lacerations, and to prevent snagging of clothing. 1926.502(b)(7), the ends of all top rails and mid-rails shall not overhang the terminal posts, except where such overhang does not constitute a projection hazard. 1926.502(b)(8), steel banding and plastic banding shall not be used as top rails or mid-rails. 1926.502(b)(9), top rails and mid-rails shall be at least 1/4 inch, 0.6 centimeters, nominal diameter or thickness to prevent cuts and lacerations. If wire rope is used for top rails, it shall be flagged at not more than 6-foot intervals with high visibility material. 1926.502(b)(10), when guardrail systems are used at hoisting areas, a chain, gate or removable guardrail section shall be placed across the access opening between guardrail sections when hoisting operations are not taking place. 1926.502(b)(11), when guardrail systems are used at holes, they shall be erected on all unprotected sides or edges of the hole. 1926.502(b)(12), when guardrail systems are used around holes used for the passage of materials, the hole shall have not more than 2 sides provided with removable guardrail sections to allow the passage of materials. When the hole is not in use, it shall be closed over with a cover, or a guardrail system shall be provided along all unprotected sides or edges. 1926.502(b)(13), when guardrail systems are used around holes which are used as points of access, such as ladderways, they shall be provided with a gate, or be so offset that a person cannot walk directly into the hole. 1926.502(b)(14), guardrail systems used on ramps and runways shall be erected along each unprotected side or edge. 1926.502(b)(15), manila, plastic or synthetic rope being used for top rails or mid-rails shall be inspected as frequently as necessary to ensure that it continues to meet the strength requirements of paragraph B3 of this section. 1926.502(c), safety net systems. Safety net systems and their use shall comply with the following provisions. 1926.502(c)(1), safety nets shall be installed as close as practicable under the walking/working surface on which employees are working, but in no case more than 30 feet (9.1 meters) below such level. When nets are used on bridges, the potential fall area from the walking/working surface to the net shall be unobstructed. 1926.502(c)(2), safety nets shall extend outward from the outermost projection of the work surface as follows. When the vertical distance from working level to horizontal plane of net is up to 5 feet, the minimum required horizontal distance of outer edge of net from the edge of the working surface is 8 feet. When the vertical distance from working level to horizontal plane of net is more than 5 feet up to 10 feet, the minimum required horizontal distance of outer edge of net from the edge of the working surface is 10 feet. When the vertical distance from working level to horizontal plane of net is more than 10 feet, the minimum required horizontal distance of outer edge of net from the edge of the working surface is 13 feet. 1926.502(c)(3), safety nets shall be installed with sufficient clearance under them to prevent contact with the surface or structures below when subjected to an impact force equal to the drop test specified in paragraph C4 of this section. 1926.502(c)(4), safety nets and their installation shall be capable of absorbing an impact force equal to that produced by the drop test specified in paragraph C4I of this section. 1926.502(c)(4)(I), except as provided in paragraph C4(2) of this section, safety nets and safety net installations shall be drop tested at the job site after initial installation and before being used as a fall protection system, whenever relocated, after major repair, and at 6-month intervals if left in one place. The drop test shall consist of a 400-pound, 180 kilograms, bag of sand 30 plus or minus 2 inches, 76 plus or minus 5 centimeters in diameter dropped into the net from the highest walking/working surface at which employees are exposed to fall hazards, but not from less than 42 inches, 1.1 meters above that level. 1926.502 C4-2. When the employer can demonstrate that it is unreasonable to perform the drop test required by paragraph C4I of this section, the employer, or a designated competent person, shall certify that the net and net installation is in compliance with the provisions of paragraphs C3 and C4I of this section by preparing a certification record prior to the net being used as a fall protection system. The certification record must include an identification of the net and net installation for which the certification record is being prepared, the date that it was determined that the identified net and net installation were in compliance with paragraph C3 of this section, and the signature of the person making the determination and certification. The most recent certification record for each net and net installation shall be available at the job site for inspection. 1926.502 C5. Defective nets shall not be used. Safety nets shall be inspected at least once a week for wear, damage, and other deterioration. Defective components shall be removed from service. Safety nets shall also be inspected after any occurrence which could affect the integrity of the safety net system. 1926.502 C6. Materials, scrap pieces, equipment, and tools which have fallen into the safety net shall be removed as soon as possible from the net and at least before the next work shift. 1926.502 C7. The maximum size of each safety net mesh opening shall not exceed 36 square inches, 230 centimeters, nor be longer than 6 inches, 15 centimeters on any side, and the opening, measured center to center of mesh ropes or webbing, shall not be longer than 6 inches, 15 centimeters. All mesh crossings shall be secured to prevent enlargement of the mesh opening. 1926.502 C8. Each safety net, or section of it, shall have a border rope for webbing with a minimum breaking strength of 5,000 pounds, 22.2 knots. 1926.502 C9. Connections between safety net panels shall be as strong as integral net components and shall be spaced not more than 6 inches, 15 centimeters apart. 1926.502 D. Personal fall arrest systems. Personal fall arrest systems and their use shall comply with the provisions set forth below. Effective January 1, 1998, body belts are not acceptable as part of a personal fall arrest system. Note, the use of a body belt in a positioning device system is acceptable and is regulated under paragraph E of this section. 1926.502 D1. Connectors shall be drop forged, pressed, or formed steel, or made of equivalent materials. 1926.502 D2. Connectors shall have a corrosion-resistant finish, and all surfaces and edges shall be smoothed to prevent damage to interfacing parts of the system. 1926.502 D3. D-rings and snap hooks shall have a minimum tensile strength of 5,000 pounds, 22.2 knots. 1926.502 D4. D-rings and snap hooks shall be proof tested to a minimum tensile load of 3,600 pounds, 16 knots, without cracking, breaking, or taking permanent deformation. 1926.502 D5. Snap hooks shall be sized to be compatible with the member to which they are connected to prevent unintentional disengagement of the snap hook by depression of the snap hook keeper by the connected member, or shall be a locking type snap hook designed and used to prevent disengagement of the snap hook by the contact of the snap hook keeper by the connected member. Effective January 1, 1998, only locking type snap hooks shall be used. 1926.502 D6. Unless the snap hook is a locking type and designed for the following connections, snap hooks shall not be engaged. 1926.502 D6 I through 1926.502 D6 V. Directly to webbing, rope or wire rope, to each other, to a D-ring to which another snap hook or other connector is attached, to a horizontal lifeline, or to any object which is incompatibly shaped or dimensioned in relation to the snap hook such that unintentional disengagement could occur by the connected object being able to depress the snap hook keeper and release itself. 1926.502 D7. on suspended scaffolds or similar work platforms with horizontal lifelines which may become vertical lifelines. The devices used to connect to a horizontal lifeline shall be capable of locking in both directions on the lifeline. 1926.502 D8 Horizontal lifelines shall be designed, installed, and used, under the supervision of a qualified person, as part of a complete personal fall arrest system, which maintains a safety factor of at least 2. 1926.502 D9 Lanyards and vertical lifelines shall have a minimum breaking strength of 5,000 pounds, 22.2 knots. 1926.502 D10 1926.502 D10 I, except as provided in paragraph D10(2) of this section, when vertical lifelines are used, each employee shall be attached to a separate lifeline. 1926.502 D10(2) During the construction of elevator shafts, 2 employees may be attached to the same lifeline in the hoistway. Provided both employees are working atop a false car that is equipped with guardrails, the strength of the lifeline is 10,000 pounds, 5,000 pounds per employee attached, 44.4 knots, and all other criteria specified in this paragraph for lifelines have been met. 1926.502 D11 Lifelines shall be protected against being cut or abraded. 1926.502 D12 Self-retracting lifelines and lanyards which automatically limit free fall distance to 2 feet (0.61 meters) or less shall be capable of sustaining a minimum tensile load of 3,000 pounds, 13.3 knots, applied to the device with the lifeline or lanyard in the fully extended position. 1926.502 D13 Self-retracting lifelines and lanyards which do not limit free fall distance to 2 feet (0.61 meters) or less, ripstitch lanyards, and tearing and deforming lanyards shall be capable of sustaining a minimum tensile load of 5,000 pounds, 22.2 knots, applied to the device with the lifeline or lanyard in the fully extended position. 1926.502 D14 Ropes and straps, webbing, used in lanyards, lifelines, and strength components of body belts and body harnesses shall be made from synthetic fibers. 1926.502 D15 Anchorages used for attachment of personal fall arrest equipment shall be independent of any anchorage being used to support or suspend platforms incapable of supporting at least 5,000 pounds, 22.2 knots, per employee attached, or shall be designed, installed, and used as follows. 1926.502 D15 I through 1926.502 D15 2 as part of a complete personal fall arrest system which maintains a safety factor of at least 2, and under the supervision of a qualified person. 1926.502 D16 Personal fall arrest systems, when stopping a fall, shall 1926.502 D16 I through 1926.502 D16 V limit maximum arresting force on an employee to 900 pounds for knots when used with a body belt. Limit maximum arresting force on an employee to 1,800 pounds, 8 knots, when used with a body harness. Be rigged such that an employee can neither free fall more than 6 feet, 1.8 meters, nor contact any lower level. Bring an employee to a complete stop and limit maximum deceleration distance an employee travels to 3.5 feet, 1.07 meters, and have sufficient strength to withstand twice the potential impact energy of an employee free falling a distance of 6 feet, 1.8 meters, or the free fall distance permitted by the system, whichever is less. Note: if the personal fall arrest system meets the criteria and protocols contained in Appendix C to Subpart M, and if the system is being used by an employee having a combined person and tool weight of less than 310 pounds, 140 kilograms, the system will be considered to be in compliance with the provisions of paragraph D16 of this section. If the system is used by an employee having a combined tool and body weight of 310 pounds, 140 kilograms, or more, then the employer must appropriately modify the criteria and protocols of the appendix to provide proper protection for such heavier weights, or the system will not be deemed to be in compliance with the requirements of paragraph D16 of this section. 1926.502 D17 The attachment point of the body belt shall be located in the center of the wearer's back. The attachment point of the body harness shall be located in the center of the wearer's back near shoulder level or above the wearer's head. 1926.502 D18 Body belts, harnesses, and components shall be used only for employee protection, as part of a personal fall arrest system or positioning device system, and not to hoist materials. 1926.502 D19. Personal fall arrest systems and components subjected to impact loading shall be immediately removed from service and shall not be used again for employee protection until inspected and determined by a competent person to be undamaged and suitable for reuse. 1926.502 D20. The employer shall provide for prompt rescue of employees in the event of a fall or shall assure that employees are able to rescue themselves. 1926.502 D21. Personal fall arrest systems shall be inspected prior to each use for wear, damage, and other deterioration, and defective components shall be removed from service. 1926.502 D22. Body belts shall be at least 1 5/8 inches, 4.1 centimeters, wide. 1926.502 D23. Personal fall arrest systems shall not be attached to guardrail systems, nor shall they be attached to hoists except as specified in other subparts of this part. 1926.502 D24. When a personal fall arrest system is used at hoist areas, it shall be rigged to allow the movement of the employee only as far as the edge of the walking/working surface. 1926.502 E. Positioning device systems. Positioning device systems and their use shall conform to the following provisions. 1926.502 E1. Positioning devices shall be rigged such that an employee cannot free fall more than 2 feet, 0.6 m. 1926.502 E2. Positioning devices shall be secured to an anchorage capable of supporting at least twice the potential impact load of an employee's fall or 3,000 pounds, 13.3 knots, whichever is greater. 1926.502 E3. Connectors shall be drop forged, pressed, or formed steel, or made of equivalent materials. 1926.502 E4. Connectors shall have a corrosion-resistant finish, and all surfaces and edges shall be smoothed to prevent damage to interfacing parts of this system. 1926.502 E5. Connecting assemblies shall have a minimum tensile strength of 5,000 pounds, 22.2 knots. 1926.502 E6. Dearings and snaphooks shall be proof-tested to a minimum tensile load of 3,600 pounds, 16 knots, without cracking, breaking, or taking permanent deformation. 1926.502 E7. Snaphooks shall be sized to be compatible with the member to which they are connected to prevent unintentional disengagement of the snaphook by depression of the snaphook keeper by the connected member, or shall be a locking-type snaphook designed and used to prevent disengagement of the snaphook by the contact of the snaphook keeper by the connected member. As of January 1, 1998, only locking-type snaphooks shall be used. 1926.502 E8. Unless the snaphook is a locking type and designed for the following connections, snaphooks shall not be engaged. 1926.502 E8I through 1926.502 E8V. Directly to webbing, rope or wire rope, to each other, to a dearing to which another snaphook or other connector is attached, to a horizontal lifeline, or to any object which is incompatibly shaped or dimensioned in relation to the snaphook, such that unintentional disengagement could occur by the connected object being able to depress the snaphook keeper and release itself. 1926.502 E9. Positioning device systems shall be inspected prior to each use for wear, damage, and other deterioration, and defective components shall be removed from service. 1926.502 E10. Body belts, harnesses, and components shall be used only for employee protection, as part of a personal fall arrest system or positioning device system, and not to hoist materials. 1926.502 F. Warning line systems. Warning line systems, see 1926.501 B10, and their use shall comply with the following provisions. 1926.502 F1 through 1926.502 F1 4. The warning line shall be erected around all sides of the roof work area. When mechanical equipment is not being used, the warning line shall be erected not less than 6 feet, 1.8 meters from the roof edge. When mechanical equipment is being used, The warning line shall be erected not less than 6 feet, 1.8 meters, from the roof edge, which is parallel to the direction of mechanical equipment operation, and not less than 10 feet, 3.1 meters, from the roof edge, which is perpendicular to the direction of mechanical equipment operation. Points of access, materials handling areas, storage areas, and hoisting areas shall be connected to the work area by an access path formed by 2 warning lines. When the path to a point of access is not in use, a rope, wire, chain, or other barricade, equivalent in strength and height to the warning line, shall be placed across the path at the point where the path intersects the warning line erected around the work area, or the path shall be offset such that a person cannot walk directly into the work area. 1926.502, F2, warning line shall consist of ropes, wires, or chains, and supporting stanchions erected as follows. 1926.502, F2I, through 1926.502, F2, the rope, wire, or chain shall be flagged at not more than 6 foot, 1.8 m intervals with high visibility material. The rope, wire, or chain shall be rigged and supported in such a way that its lowest point, including sag, is no less than 34 inches, 0.9 m, from the walking/working surface, and its highest point is no more than 39 inches, 1 meter, from the walking/working surface. After being erected, with the rope, wire, or chain attached, stanchions shall be capable of resisting, without tipping over, a force of at least 16 pounds, 71 N, applied horizontally against the stanchion, 30 inches, 0.8 m, above the walking/working surface, perpendicular to the warning line, and in the direction of the floor, roof, or platform edge. The rope, wire, or chain shall have a minimum tensile strength of 500 pounds, 2.22 knots, and after being attached to the stanchions, shall be capable of supporting, without breaking, the loads applied to the stanchions as prescribed in paragraph F2(3) of this section. And the line shall be attached at each stanchion in such a way that pulling on one section of the line between stanchions will not result in slack being taken up in adjacent sections before the stanchion tips over. 1926.502, F3, no employee shall be allowed in the area between a roof edge and a warning line unless the employee is performing roofing work in that area. 1926.502, F4, mechanical equipment on roofs shall be used or stored only in areas where employees are protected by a warning line system, guardrail system, or personal fall arrest system. 1926.502, G, controlled access zones. Controlled access zones, see 1926.501, B9, and 1926.502, K, and their use shall conform to the following provisions. 1926.502, G1, through 1926.502, G1, 4, when used to control access to areas where leading edge and other operations are taking place, the controlled access zone shall be defined by a control line or by any other means that restricts access. When control lines are used, they shall be erected not less than 6 feet, 1.8 meters, nor more than 25 feet, 7.7 meters, from the unprotected or leading edge, except when erecting precast concrete members. When erecting precast concrete members, the control line shall be erected not less than 6 feet, 1.8 meters, nor more than 60 feet, 18 meters, or half the length of the member being erected, whichever is less, from the leading edge. The control line shall extend along the entire length of the unprotected or leading edge and shall be approximately parallel to the unprotected or leading edge. The control line shall be connected on each side to a guardrail system or wall. 1926.502, G2, when used to control access to areas where overhand bricklaying and related work are taking place. 1926.502, G2I, through 1926.502, G2, 4, the controlled access zone shall be defined by a control line erected not less than 10 feet, 3.1 meters, nor more than 15 feet, 4.5 meters, from the working edge. The control line shall extend for a distance sufficient for the controlled access zone to enclose all employees performing overhand bricklaying and related work at the working edge and shall be approximately parallel to the working edge. Additional control lines shall be erected at each end to enclose the controlled access zone. Only employees engaged in overhand bricklaying or related work shall be permitted in the controlled access zone. 1926.502, G3, control lines shall consist of ropes, wires, tapes, or equivalent materials, and supporting stanchions as follows. 1926.502, G3I, through 1926.502, G3, 3, each line shall be flagged or otherwise clearly marked at not more than 6 foot, 1.8 m intervals with high visibility material. Each line shall be rigged and supported in such a way that its lowest point, including sag, is not less than 39 inches 1 meter from the walking/working surface, and its highest point is not more than 45 inches 1.3 meters 50 inches 1.3 meters when overhand bricklaying operations are being performed from the walking/working surface. Each line shall have a minimum breaking strength of 200 pounds, 0.88 kN. 1926.502 G4. On floors and roofs where guardrail systems are not in place prior to the beginning of overhand bricklaying operations, controlled access zones shall be enlarged, as necessary, to enclose all points of access, material handling areas, and storage areas. 1926.502 G5. On floors and roofs where guardrail systems are in place, but need to be removed to allow overhand bricklaying work or leading edge work to take place, only that portion of the guardrail necessary to accomplish the day's work shall be removed. 1926.502 H. Safety Monitoring Systems. Safety monitoring systems, see 1926.501 B10 and 1926.502 K, and their use shall comply with the following provisions. 1926.502 H1 through 1926.502 H1 V. The employer shall designate a competent person to monitor the safety of other employees, and the employer shall ensure that the safety monitor complies with the following requirements. The safety monitor shall be competent to recognize fall hazards. The safety monitor shall warn the employee when it appears that the employee is unaware of a fall hazard or is acting in an unsafe manner. The safety monitor shall be on the same walking/working surface and within visual sighting distance of the employee being monitored. The safety monitor shall be close enough to communicate orally with the employee, and the safety monitor shall not have other responsibilities which could take the monitor's attention from the monitoring function. 1926.502 H2. Mechanical equipment shall not be used or stored in areas where safety monitoring systems are being used to monitor employees engaged in roofing operations on low-slope roofs. 1926.502 H3. No employee, other than an employee engaged in roofing work on low-sloped roofs, or an employee covered by a fall protection plan, shall be allowed in an area where an employee is being protected by a safety monitoring system. 1926.502 H4. Each employee working in a controlled access zone shall be directed to comply promptly with fall hazard warnings from safety monitors. 1926.502 I. Covers. Covers for holes in floors, roofs, and other walking/working surfaces shall meet the following requirements. 1926.502 I1 through 1926.502 I4. Covers located in roadways and vehicular aisles shall be capable of supporting, without failure, at least twice the maximum axle load of the largest vehicle expected to cross over the cover. All other covers shall be capable of supporting, without failure, at least twice the weight of employees, equipment, and materials that may be imposed on the cover at any one time. All covers shall be secured when installed so as to prevent accidental displacement by the wind, equipment, or employees. All covers shall be color-coded, or they shall be marked with the word hole or cover to provide warning of the hazard. Note: this provision does not apply to cast iron manhole covers or steel grates used on streets or roadways. 1926.502 J. Protection from falling objects. Falling object protection shall comply with the following provisions. 1926.502 J1. Toe boards, when used as falling object protection, shall be erected along the edge of the overhead walking/working surface for a distance sufficient to protect employees below. 1926.502 J2. Toe boards shall be capable of withstanding, without failure, a force of at least 50 pounds, 222 N, applied in any downward or outward direction at any point along the toe board. 1926.502 J3. Toe boards shall be a minimum of 3.5 inches, 9 centimeters, in vertical height from their top edge to the level of the walking/working surface. They shall have not more than 1/4 inch, 0.6 centimeters, clearance above the walking/working surface. They shall be solid or have openings not over 1 inch, 2.5 centimeters, in greatest dimension. 1926.502 J4. Where tools, equipment, or materials are piled higher than the top edge of a towboard, paneling or screening shall be erected from the walking/working surface or towboard to the top of a guardrail system's top rail or mid-rail, for a distance sufficient to protect employees below. 1926.502 J5. Guardrail systems, when used as falling object protection, shall have all openings small enough to prevent passage of potential falling objects. 1926.502 J6. During the performance of overhand bricklaying and related work. 1926.502 J6 I. No materials or equipment except masonry and mortar shall be stored within 4 feet, 1.2 meters of the working edge. 1926.502 J6 2. Excess mortar, broken or scattered masonry units, and all other materials and debris shall be kept clear from the work area by removal at regular intervals. 1926.502 J7. During the performance of roofing work. 1926.502 J7 I. Materials and equipment shall not be stored within 6 feet, 1.8 meters of a roof edge unless guardrails are erected at the edge. 1926.502 J7 the second. Materials which are piled, grouped, or stacked near a roof edge shall be stable and self-supporting. 1926.502 J8. Canopies, when used as falling object protection, shall be strong enough to prevent collapse and to prevent penetration by any objects which may fall onto the canopy. 1926.502 K. Fall Protection Plan. This option is available only to employees engaged in leading edge work, precast concrete erection work, or residential construction work. See 1926.501, B2, B12, and B13, who can demonstrate that it is infeasible or it creates a greater hazard to use conventional fall protection equipment. The fall protection plan must conform to the following provisions. 1926.502, K1. The fall protection plan shall be prepared by a qualified person and developed specifically for the site where the leading edge work, precast concrete work, or residential construction work is being performed, and the plan must be maintained up to date. 1926.502, K2. Any changes to the fall protection plan shall be approved by a qualified person. 1926.502, K3. A copy of the fall protection plan with all approved changes shall be maintained at the job site. 1926.502, K4. The implementation of the fall protection plan shall be under the supervision of a competent person. 1926.502, K5. The fall protection plan shall document the reasons why the use of conventional fall protection systems, guardrail systems, personal fall arrest systems, or safety net systems are infeasible or why their use would create a greater hazard. 1926.502, K6. The fall protection plan shall include a written discussion of other measures that will be taken to reduce or eliminate the fall hazard for workers who cannot be provided with protection from the conventional fall protection systems. For example, the employer shall discuss the extent to which scaffolds, ladders, or vehicle-mounted work platforms can be used to provide a safer working surface and thereby reduce the hazard of falling. 1926.502, K7. The fall protection plan shall identify each location where conventional fall protection methods cannot be used. These locations shall then be classified as controlled access zones, and the employer must comply with the criteria in paragraph G of this section. 1926.502, K8. Where no other alternative measure has been implemented, the employer shall implement a safety monitoring system in conformance with 1926.502, H. 1926.502, K9. The fall protection plan must include a statement which provides the name or other method of identification for each employee who is designated to work in controlled access zones. No other employees may enter controlled access zones. 1926.502, K10. In the event an employee falls, or some other related, serious incident occurs, e.g., a near miss, the employer shall investigate the circumstances of the fall or other incident to determine if the fall protection plan needs to be changed, e.g., new practices, procedures, or training, and shall implement those changes to prevent similar types of falls or incidents. 1926.503. Training requirements. The following training provisions supplement and clarify the requirements of 1926.21 regarding the hazards addressed in Subpart M of this part. 1926.503a. Training Program. 1926.503a.1. The employer shall provide a training program for each employee who might be exposed to fall hazards. The program shall enable each employee to recognize the hazards of falling and shall train each employee in the procedures to be followed in order to minimize these hazards. 1926.503a.2. The employer shall assure that each employee has been trained, as necessary, by a competent person qualified in the following areas. 1926.503a.2i through 1926.503a.2.8. The nature of fall hazards in the work area. The correct procedures for erecting, maintaining, disassembling, and inspecting the fall protection systems to be used. The use and operation of guardrail systems, personal fall arrest systems, safety net systems, warning line systems, safety monitoring systems, controlled access zones, and other protection to be used. The role of each employee in the safety monitoring system when this system is used. The limitations on the use of mechanical equipment during the performance of roofing work on low-sloped roofs. The correct procedures for the handling and storage of equipment and materials and the erection of overhead protection. And the role of employees in fall protection plans. The standards contained in this subpart. 1926.503b. Certification of training. 1926.503b.1. The employer shall verify compliance with paragraph A of this section by preparing a written certification record. The written certification record shall contain the name or other identity of the employee trained, the dates of the training, and the signature of the person who conducted the training or the signature of the employer. If the employer relies on training conducted by another employer or completed prior to the effective date of this section, the certification record shall indicate the date the employer determined the prior training was adequate rather than the date of actual training. 1926.503b.2. The latest training certification shall be maintained. 1926.503c. Retraining. When the employer has reason to believe that any affected employee who has already been trained does not have the understanding and skill required by paragraph A of this section, the employer shall retrain each such employee. Circumstances where retraining is required include, but are not limited to, situations where 1926.503c.1. Changes in the workplace render previous training obsolete, or 1926.503c.2. Changes in the types of fall protection systems or equipment to be used render previous training obsolete, or 1926.503c.3. Inadequacies in an affected employee's knowledge or use of fall protection systems or equipment indicate that the employee has not retained the requisite understanding or skill. Note: the following appendices to Subpart M of this part serve as non-mandatory guidelines to assist employers in complying with the appropriate requirements of Subpart M of this part. Appendix A. Determining roof widths, non-mandatory guidelines for complying with 1926.501b.10. 1. This appendix serves as a guideline to assist employers complying with the requirements of Section 1926.501b.10. Section 1926.501b.10 allows the use of a safety monitoring system alone as a means of providing fall protection during the performance of roofing operations on low-sloped roofs 50 feet, 15.25 meters, or less in width. Each example in the appendix shows a roof plan or plans and indicates where each roof or roof area is to be measured to determine its width. Section views or elevation views are shown where appropriate. Some examples show correct and incorrect subdivisions of irregularly shaped roofs divided into smaller, regularly shaped areas. In all examples, the dimension selected to be the width of an area is the lesser of the two primary dimensions of the area, as viewed from above. Example A shows that on a simple rectangular roof, width is the lesser of the two primary overall dimensions. This is also the case with roofs which are sloped toward or away from the roof center, as shown in example B. 2. Many roofs are not simple rectangles. Such roofs may be broken down into subareas as shown in example C. The process of dividing a roof area can produce many different configurations. Example C gives the general rule of using dividing lines of minimum length to minimize the size and number of the areas which are potentially less than 50 feet, 15.25 meters, wide. The intent is to minimize the number of roof areas where safety monitoring systems alone are sufficient protection. 3. Roofs which are comprised of several separate, non-contiguous roof areas, as in example D, may be considered as a series of individual roofs. Some roofs have penthouses, additional floors, courtyard openings, or similar architectural features. Example E shows how the rule for dividing roofs into subareas is applied to such configurations. Irregular, non-rectangular roofs must be considered on an individual basis, as shown in example F. Example of a rectangular-shaped roof. Example B, sloped rectangular roofs. Example C, irregularly shaped roofs with rectangular-shaped sections. Such roofs are to be divided into subareas by using dividing lines of minimum length to minimize the size and number of the areas which are potentially less than or equal to feet, 15.25 meters, in width. In order to limit the size of roof areas where the safety monitoring system alone can be used, 1926.501, b. 10. Dotted lines are used in the examples to show the location of dividing lines. W denotes correct measurements and circle W denotes incorrect measurements of width. Example C, correct and incorrect irregularly shaped roofs with rectangular shaped sections. Example C, correct and incorrect irregularly shaped roofs with rectangular shaped sections. Example C, correct and incorrect irregularly shaped roofs with rectangular shaped sections. Example D, separate, non-contiguous roof areas. Example D, separate, non-contiguous roof areas. Example E, roofs with penthouses, open courtyards, additional floors, etc. Such roofs are to be divided into subareas by using divided lines of minimum length to minimize the size and number of areas which are potentially less than or equal to 50 feet, 15.25 meters, in width. In order to limit the size of roof areas where the safety monitor system alone can be used, 1926.501, b. 10. Dotted lines are used in the examples to show the location of dividing lines. W denotes correct measurements and circle W denotes incorrect measurements of width. Correct example of example E or roofs with penthouses, open courtyards, additional floors, etc. Incorrect example of example E. Example F, irregular, non-rectangular shaped roofs. Example F, irregular, non-rectangular shaped roofs. Appendix B, Guardrail Systems, Non-Mandatory Guidelines for Complying with 1926.502, b. The standard requires guardrail systems and components to be designed and built to meet the requirements of 1926.502, b. 3, 4, and 5. This appendix serves as a non-mandatory guideline to assist employers in complying with these requirements. An employer may use these guidelines as a starting point for designing guardrail systems. However, the guidelines do not provide all the information necessary to build a complete system, and the employer is still responsible for designing and assembling these components in such a way that the completed system will meet the requirements of 1926.502, b. 3, 4, and 5. Components for which no specific guidelines are given in this appendix, e.g., joints, base connections, components made with other materials, and components with other dimensions, must also be designed and constructed in such a way that the completed system meets the requirements of 1926.502. 1. For wood railings, wood components shall be minimum 1,500 lbft/in. 2. Fiber, stress grade, construction grade lumber. The posts shall be at least 2 inch by 4 inch, 5 cm x 10 cm, lumber spaced not more than 8 feet, 2.4 meters apart on centers. The top rail shall be at least 2 inch by 4 inch, 5 cm x 10 cm, lumber. The intermediate rail shall be at least 1 inch by 6 inch, 2.5 cm x 15 cm, lumber. All lumber dimensions are nominal sizes as provided by the American Softwood Lumber Standards, dated January 1970. 2. For pipe railings, posts, top rails, and intermediate railings shall be at least 1 1/2 inches nominal diameter, Schedule 40 pipe, with posts spaced not more than 8 feet, 2.4 meters apart on centers. 3. For structural steel railings, posts, top rails, and intermediate rails shall be at least 2 inch by 2 inch, 5 cm x 10 cm, by 3/8 inch, 1.1 cm, angles, with posts spaced not more than 8 feet, 2.4 meters apart on centers. Appendix C. Personal Fall Arrest Systems, Non-Mandatory Guidelines for Complying with 1926.502 d. I. Test Methods for Personal Fall Arrest Systems and Positioning Device Systems. A. General. This appendix serves as a non-mandatory guideline to assist employers comply with the requirements in 1926.502 d. Paragraphs B, C, D, and E of this appendix describe test procedures which may be used to determine compliance with the requirements in 1926.502 d. 16. As noted in Appendix D of this subpart, the test methods listed here in Appendix C can also be used to assist employers comply with the requirements in 1926.502 E, 3, and 4 for positioning device systems. B. General conditions for all tests in the appendix to 1926.502 d. 1. Lifelines, lanyards, and deceleration devices should be attached to an anchorage and connected to the body belt or body harness in the same manner as they would be when used to protect employees. 2. The anchorage should be rigid and should not have a deflection greater than 0.04 inches, 1 mm, when a force of 2,250 pounds, 10 knots, is applied. 3. The frequency response of the load measuring instrumentation should be 500 Hz. 4. The test weight used in the strength and force tests should be a rigid, metal, cylindrical or torso-shaped object with a girth of 38 inches plus or minus 4 inches, 96 centimeters plus or minus 10 centimeters. 5. The lanyard or lifeline used to create the free fall distance should be supplied with the system, or in its absence, the least elastic lanyard or lifeline available to be used with the system. 6. The test weight for each test should be hoisted to the required level and should be quickly released without having any appreciable motion imparted to it. 7. The system's performance should be evaluated taking into account the range of environmental conditions for which it is designed to be used. 8. Following the test, the system need not be capable of further operation. C. Strength test. 1. During the testing of all systems, a test weight of 300 pounds plus or minus 5 pounds, 135 kilograms plus or minus 2.5 kilograms, should be used. See paragraph B, 4 of this section. 2. The test consists of dropping the test weight once. A new and used system should be used for each test. 3. For lanyard systems, the lanyard length should be 6 feet plus or minus 2 inches, 1.83 m plus or minus 5 centimeters, as measured from the fixed anchorage to the attachment on the body belt or body harness. 4. For rope grab type deceleration systems, the length of the lifeline above the centerline of the grabbing mechanism to the lifeline's anchorage point should not exceed 2 feet 0.61 meters. 5. For lanyard systems, for systems with deceleration devices which do not automatically limit free fall distance to 2 feet, 0.61 m, or less, and for systems with deceleration devices which have a connection distance in excess of 1 foot, 0.3 m, measured between the centerline of the lifeline and the attachment point to the body belt or harness, the test weight should be rigged to free fall a distance of 7.5 feet, 2.3 meters from a point that is 1.5 feet, 0.46 m, above the anchorage point, to its hanging location, 6 feet below the anchorage. The test weight should fall without interference, obstruction, or hitting the floor or ground during the test. In some cases, a non-elastic wire lanyard of sufficient length may need to be added to the system, for test purposes, to create the necessary free fall distance. 6. For deceleration device systems with integral lifelines or lanyards which automatically limit free fall distance to 2 feet 0.61 meters or less, the test weight should be rigged to free fall a distance of 4 feet 1.22 meters. 7. Any weight which detaches from the belt or harness has failed the strength test. D. Force test. 1. General. The test consists of dropping the respective test weight once as specified in paragraph D2I or D3I of this section. A new and used system should be used for each test. 2. For lanyard systems. I. A test weight of 220 pounds plus or minus 3 pounds, 100 kilograms plus or minus 1.6 kilograms, should be used. See paragraph B, 4 of this appendix. 2. Lanyard length should be 6 feet plus or minus 2 inches, 1.83 m plus or minus 5 centimeters, as measured from the fixed anchorage to the attachment on the body belt or body harness. 3. The test weight should fall free from the anchorage level to its hanging location, a total of 6 feet, 1.83 meters, free fall distance, without interference, obstruction, or hitting the floor or ground during the test. 3. For all other systems. I. A test weight of 220 pounds plus or minus 3 pounds, 100 kilograms plus or minus 1.6 kilograms, should be used. See paragraph B4 of this appendix. 2. The free fall distance to be used in the test should be the maximum fall distance physically permitted by the system during normal use conditions, up to a maximum free fall distance for the test weight of 6 feet, 1.83 meters, except as follows. A. For deceleration systems which have a connection link or lanyard, the test weight should free fall a distance equal to the connection distance, measured between the centerline of the lifeline and the attachment point to the body belt or harness. B. For deceleration device systems with integral lifelines or lanyards which automatically limit free fall distance to 2 feet, 0.61 meters or less, the test weight should free fall a distance equal to that permitted by the system in normal use. For example, to test a system with a self-retracting lifeline or lanyard, the test weight should be supported and the system allowed to retract the lifeline or lanyard as it would in normal use. The test weight would then be released and the force and deceleration distance measured. 4. A system fails the force test if the recorded maximum arresting force exceeds 1,260 pounds, 5.6 knots, when using a body belt, and/or exceeds 2,520 pounds, 11.2 knots, when using a body harness. 5. The maximum elongation and deceleration distance should be recorded during the force test. E. Deceleration device tests. 1. General. The device should be evaluated or tested under the environmental conditions, such as rain, ice, grease, dirt, type of lifeline, etc., for which the device is designed. 2. Rope grab type deceleration devices. I. Devices should be moved on a lifeline 1,000 times over the same length of line at distance of not less than 1 foot, 30.5 centimeters, and the mechanism should lock each time. 2. Unless the device is permanently marked to indicate the types of lifeline which must be used, several types, different diameters and different materials of lifelines should be used to test the device. 3. Other self-activating type deceleration devices. The locking mechanisms of other self-activating type deceleration devices designed for more than one arrest should lock each of 1,000 times as they would in normal service. 2. Additional non-mandatory guidelines for personal fall arrest systems. The following information constitutes additional guidelines for use in complying with requirements for a personal fall arrest system. Selection and use considerations. 1. The kind of personal fall arrest system selected should match the particular work situation, and any possible free fall distance should be kept to a minimum. Consideration should be given to the particular work environment. For example, the presence of acids, dirt, moisture, oil, grease, etc., and their effect on the system should be evaluated. Hot or cold environments may also have an adverse effect on the system. Wire rope should not be used where an electrical hazard is anticipated. As required by the standard, the employer must plan to have means available to promptly rescue an employee should a fall occur, since the suspended employee may not be able to reach a work level independently. 2. Where lanyards, connectors, and lifelines are subject to damage by work operations such as welding, chemical cleaning, and sandblasting, the component should be protected, or other securing systems should be used. The employer should fully evaluate the work conditions and environment, including seasonal weather changes, before selecting the appropriate personal fall protection system. Once in use, the system's effectiveness should be monitored. In some cases, a program for cleaning and maintenance of the system may be necessary. B. Testing considerations. Before purchasing or putting into use a personal fall arrest system, an employer should obtain from the supplier information about the system based on its performance during testing so that the employer can know if the system meets this standard. Testing should be done using recognized test methods. This appendix contains test methods recognized for evaluating the performance of fall arrest systems. Not all systems may need to be individually tested, the performance of some systems may be based on data and calculations derived from testing of similar systems, provided that enough information is available to demonstrate similarity of function and design. C. Component compatibility considerations. Ideally, a personal fall arrest system is designed, tested, and supplied as a complete system. However, it is common practice for lanyards, connectors, lifelines, deceleration devices, body belts, and body harnesses to be interchanged since some components wear out before others. The employer and employee should realize that not all components are interchangeable. For instance, a lanyard should not be connected between a body belt or harness and a deceleration device of the self-retracting type, since this can result in additional free fall for which the system was not designed. Any substitution or change to a personal fall arrest system should be fully evaluated or tested by a competent person to determine that it meets the standard before the modified system is put in use. D. Employee training considerations. Thorough employee training in the selection and use of personal fall arrest systems is imperative. Employees must be trained in the safe use of the system. This should include the following: application limits, proper anchoring and tie-off techniques, estimation of free fall distance, including determination of deceleration distance and total fall distance to prevent striking a lower level, methods of use, and inspection and storage of the system. Careless or improper use of the equipment can result in serious injury or death. Employers and employees should become familiar with the material in this appendix, as well as manufacturers' recommendations, before a system is used. Of uppermost importance is the reduction in strength caused by certain tie-offs, such as using knots, tying around sharp edges, etc., and maximum permitted free fall distance. Also, to be stressed are the importance of inspections prior to use, the limitations of the equipment, and unique conditions at the worksite which may be important in determining the type of system to use. E. Instruction considerations. Employers should obtain comprehensive instructions from the supplier as to the system's proper use and application, including, where applicable, 1. The force measured during the sample force test. 2. The maximum elongation measured for lanyards during the force test. 3. The deceleration distance measured for deceleration devices during the force test. 4. Caution statements on critical use limitations. 5. Application limits. 6. Proper hookup, anchoring and tie-off techniques, including the proper deering or other attachment point to use on the body belt and harness for fall arrest. 7. Proper climbing techniques. 8. Methods of inspection, use, cleaning, and storage. And 9. Specific lifelines which may be used. This information should be provided to employees during training. F. Rescue considerations. As required by 1926.502 D-20, when personal fall arrest systems are used, the employer must assure that employees can be promptly rescued or can rescue themselves should a fall occur. The availability of rescue personnel, ladders, or other rescue equipment should be evaluated. In some situations, equipment which allows employees to rescue themselves after the fall has been arrested may be desirable, such as devices which have descent capability. G. Inspection considerations. As required by 1926.502 D-21, personal fall arrest systems must be regularly inspected. Any component with any significant defect, such as cuts, tears, abrasions, mold, or undue stretching, alterations or additions which might affect its efficiency, damage due to deterioration, contact with fire, acids, or other corrosives, distorted hooks or faulty hook springs, tongues unfitted to the shoulder of buckles, loose or damaged mountings, non-functioning parts, or wearing or internal deterioration in the ropes must be withdrawn from service immediately, and should be tagged or marked as unusable or destroyed. H. Tie-off considerations. One of the most important aspects of personal fall protection systems is fully planning the system before it is put into use. Probably the most overlooked component is planning for suitable anchorage points. Such planning should ideally be done before the structure or building is constructed so that anchorage points can be incorporated during construction for use later for window cleaning or other building maintenance. If properly planned, these anchorage points may be used during construction as well as afterwards. Properly planned anchorages should be used if they are available. In some cases, anchorages must be installed immediately prior to use. In such cases, a registered professional engineer with experience in designing fall protection systems, or another qualified person with appropriate education and experience should design an anchor point to be installed. 2. In other cases, the agency recognizes that there will be a need to devise an anchor point from existing structures. Examples of what might be appropriate anchor points are steel members or I-beams. If an acceptable strap is available for the connection, do not use a lanyard with a snap hook clipped onto itself. Large I-bolts made of an appropriate grade steel, guardrails or railings if they have been designed for use as an anchor point, or masonry or wood members only if the attachment point is substantial and precautions have been taken to assure that bolts or other connectors will not pull through. A qualified person should be used to evaluate the suitability of these makeshift anchorages with a focus on proper strength. 2. Employers and employees should at all times be aware that the strength of a personal fall arrest system is based on its being attached to an anchoring system which does not reduce the strength of the system, such as a properly dimensioned I-bolt/snap hook anchorage. Therefore, if a means of attachment is used that will reduce the strength of the system, that component should be replaced by a stronger one, but one that will also maintain the appropriate maximum arrest force characteristics. 3. Tie-off using a knot in a rope lanyard or lifeline, at any location, can reduce the lifeline or lanyard strength by 50% or more. Therefore, a stronger lanyard or lifeline should be used to compensate for the weakening effect of the knot, or the lanyard length should be reduced, or the tie-off location raised, to minimize free fall distance, or the lanyard or lifeline should be replaced by one which has an appropriately incorporated connector to eliminate the need for a knot. 4. Tie-off of a rope lanyard or lifeline around an H or I-beam or similar support can reduce its strength as much as 70% due to the cutting action of the beam edges. Therefore, use should be made of a webbing lanyard or wire core lifeline around the beam, or the lanyard or lifeline should be protected from the edge, or free fall distance should be greatly minimized. 5. Tie-off where the line passes over or around rough or sharp surfaces reduces strength drastically. Such a tie-off should be avoided, or an alternative tie-off rigging should be used. Such alternatives may include use of a snap hook/D-ring connection, wire rope tie-off, an effective padding of the surfaces, or an abrasion resistance strap around or over the problem surface. 6. Horizontal lifelines may, depending on their geometry and angle of sag, be subjected to greater loads than the impact load imposed by an attached component. When the angle of horizontal lifeline sag is less than 30 degrees, the impact force imparted to the lifeline by an attached lanyard is greatly amplified. For example, with a sag angle of 15 degrees, the force amplification is about 2:1, and at 5 degrees sag, it is about 6:1. Depending on the angle of sag and the line's elasticity, the strength of the horizontal lifeline and the anchorages to which it is attached should be increased a number of times over that of the lanyard. Extreme care should be taken in considering a horizontal lifeline for multiple tie-offs. The reason for this is that in multiple tie-offs to a horizontal lifeline, if one employee falls, the movement of the falling employee and the horizontal lifeline during arrest of the fall may cause other employees to fall also. Horizontal lifeline and anchorage strength should be increased for each additional employee to be tied off. For these and other reasons, the design of systems using horizontal lifelines must only be done by qualified persons. Testing of installed lifelines and anchors prior to use is recommended. 7. The strength of an I-bolt is rated along the axis of the bolt, and its strength is greatly reduced if the force is applied at an angle to this axis, in the direction of shear. Also, care should be exercised in selecting the proper diameter of the eye to avoid accidental disengagement of snap hooks not designed to be compatible for the connection. 8. Due to the significant reduction in the strength of the lifeline/lanyard, in some cases, as much as a 70% reduction, the sliding hitch knot, prusik, should not be used for lifeline/lanyard connections except in emergency situations where no other available system is practical. The 1N1 sliding hitch knot should never be used because it is unreliable in stopping a fall. The 2N2 or 3N3 knot, preferable, may be used in emergency situations. However, care should be taken to limit free fall distance to a minimum because of reduced lifeline/lanyard strength. Vertical lifeline considerations. As required by the standard, each employee must have a separate lifeline, except employees engaged in constructing elevator shafts who are permitted to have 2 employees on one lifeline when the lifeline is vertical. The reason for this is that in multiple tie-offs to a single lifeline, if one employee falls, the movement of the lifeline during the arrest of the fall may pull other employees' lanyards, causing them to fall as well. J. Snap hook considerations. 1. Although not required by this standard for all connections until January 1, 1998, locking snap hooks designed for connection to suitable objects of sufficient strength are highly recommended in lieu of the non-locking type. Locking snap hooks incorporate a positive locking mechanism in addition to the spring-loaded keeper, which will not allow the keeper to open under moderate pressure without someone first releasing the mechanism. Such a feature, properly designed, effectively prevents rollout from occurring. 2. As required by 1926.502 D6, the following connections must be avoided unless properly designed locking snap hooks are used, because they are conditions which can result in rollout when a non-locking snap hook is used. I. Direct connection of a snap hook to a horizontal lifeline. 2. Two or more snap hooks connected to one D-ring. 3. Two snap hooks connected to each other. 4. A snap hook connected back on its integral lanyard. V. A snap hook connected to a webbing loop or webbing lanyard. 6. Improper dimensions of the D-ring, rebar, or other connection point in relation to the snap hook dimensions which would allow the snap hook keeper to be depressed by a turning motion of the snap hook. K. Free fall considerations. The employer and employee should at all times be aware that a system's maximum arresting force is evaluated under normal use conditions established by the manufacturer, and in no case using a free fall distance in excess of 6 feet, 1.8 meters. A few extra feet of free fall can significantly increase the arresting force on the employee, possibly to the point of causing injury. Because of this, the free fall distance should be kept at a minimum, and, as required by the standard, in no case greater than 6 feet, 1.8 meters. To help assure this, the tie-off attachment point to the lifeline or anchor should be located at or above the connection point of the fall arrest equipment to belt or harness. Since otherwise additional free fall distance is added to the length of the connecting means, i.e., lanyard attaching to the working surface will often result in a free fall greater than 6 feet, 1.8 meters. For instance, if a 6-foot, 1.8 m lanyard is used, the total free fall distance will be the distance from the working level to the body belt or harness attachment point plus the 6 feet, 1.8 meters of lanyard length. Another important consideration is that the arresting force which the fall system must withstand also goes up with greater distances of free fall, possibly exceeding the strength of the system. L. Elongation and deceleration distance considerations. Other factors involved in a proper tie-off are elongation and deceleration distance. During the arresting of a fall, a lanyard will experience a length of stretching or elongation, whereas activation of a deceleration device will result in a certain stopping distance. These distances should be available with the lanyard or device's instructions and must be added to the free fall distance to arrive at the total fall distance before an employee is fully stopped. The additional stopping distance may be very significant if the lanyard or deceleration device is attached near or at the end of a long lifeline, which may itself add considerable distance due to its own elongation. As required by the standard, sufficient distance to allow for all of these factors must also be maintained between the employee and obstructions below, to prevent an injury due to impact before the system fully arrests the fall. In addition, a minimum of 12 feet, 3.7 meters of lifeline should be allowed below the securing point of a rope grab type deceleration device, and the end terminated to prevent the device from sliding off the lifeline. Alternatively, the lifeline should extend to the ground or the next working level below. These measures are suggested to prevent the worker from inadvertently moving past the end of the lifeline and having the rope grab become disengaged from the lifeline. M. Obstruction considerations. The location of the tie-off should also consider the hazard of obstructions in the potential fall path of the employee. Tie-offs which minimize the possibilities of exaggerated swinging should be considered. In addition, when a body belt is used, the employee's body will go through a horizontal position to a jackknifed position during the arrest of all falls. Thus, obstructions which might interfere with this motion should be avoided or a severe injury could occur. N. Other considerations. Because of the design of some personal fall arrest systems, additional considerations may be required for proper tie-off. For example, heavy deceleration devices of the self-retracting type should be secured overhead in order to avoid the weight of the device having to be supported by the employee. Also, if self-retracting equipment is connected to a horizontal lifeline, the sag in the lifeline should be minimized to prevent the device from sliding down the lifeline to a position which creates a swing hazard during fall arrest. In all cases, manufacturer's instructions should be followed. Appendix D. Positioning Device Systems, Non-Mandatory Guidelines for Complying with 1926.502(e). Testing Methods for Positioning Device Systems. This appendix serves as a non-mandatory guideline to assist employers comply with the requirements for positioning device systems in 1926.502(e). Paragraphs B, C, D, and E of Appendix C of Subpart M relating to 1926.502(d) personal fall arrest systems set forth test procedures which may be used, along with the procedures listed below, to determine compliance with the requirements for positioning device systems in 1926.502(e)(3) and 4 of Subpart M. General. 1. Single strap positioning devices shall have one end attached to a fixed anchorage and the other end connected to a body belt or harness in the same manner as they would be used to protect employees. Double strap positioning devices, similar to window cleaners' belts, shall have one end of the strap attached to a fixed anchorage and the other end shall hang free. The body belt or harness shall be attached to the strap in the same manner as it would be used to protect employees. The two strap ends shall be adjusted to their maximum span. 2. The fixed anchorage shall be rigid, and shall not have a deflection greater than 0.04 inches, 1 mm, when a force of 2,250 pounds, 10 knots, is applied. 3. During the testing of all systems, a test weight of 250 pounds plus or minus 3 pounds, 113 kilograms plus or minus 1.6 kilograms, shall be used. The weight shall be a rigid object with a girth of 38 inches plus or minus 4 inches, 96 centimeters plus or minus 10 centimeters. 4. Each test shall consist of dropping the specified weight one time without failure of the system being tested. A new system shall be used for each test. 5. The test weight for each test shall be hoisted exactly 4 feet, 1.2 m above its at-rest position, and shall be dropped so as to permit a vertical free fall of 4 feet, 1.2 meters. 6. The test is failed whenever any breakage or slippage occurs which permits the weight to fall free of the system. 7. Following the test, the system need not be capable of further operation, however, all such incapacity shall be readily apparent. 2. Inspection considerations. As required in 1926.502(e)(5), positioning device systems must be regularly inspected. Any component with any significant defect, such as cuts, tears, abrasions, mold, or undue stretching, alterations or additions which might affect its efficiency, damage due to deterioration, contact with fire, acids, or other corrosives, distorted hooks or faulty hook springs, tongues unfitted to the shoulder of buckles, loose or damaged mountings, non-functioning parts, or wearing or internal deterioration in the ropes must be withdrawn from service immediately, and should be tagged or marked as unusable or destroyed. Appendix E. Sample Fall Protection Plan Non-Mandatory Guidelines for Complying with 1926.502(k). Employers engaged in leading-edge work, precast concrete construction work and residential construction work who can demonstrate that it is infeasible or creates a greater hazard to use conventional fall protection systems must develop and follow a fall protection plan. Below are sample fall protection plans developed for precast concrete construction and residential work that could be tailored to be site-specific for other precast concrete or residential job site. This sample plan can be modified to be used for other work involving leading-edge work. The sample plan outlines the elements that must be addressed in any fall protection plan. The reasons outlined in this sample fall protection plan are for illustrative purposes only and are not necessarily a valid, acceptable rationale, unless the conditions at the job site are the same as those covered by these sample plans, for not using conventional fall protection systems for a particular precast concrete or residential construction work site. However, the sample plans provide guidance to employers on the type of information that is required to be discussed in fall protection plans. Sample Fall Protection Plans. Fall Protection Plan for Precast/Pre-Stress Concrete Structures. This fall protection plan is specific for the following project: location of job, erecting company, date plan prepared or modified, Plan prepared by, plan approved by, plan supervised by. The following fall protection plan is a sample program prepared for the prevention of injuries associated with falls. A fall protection plan must be developed and evaluated on a site-by-site basis. It is recommended that erectors discuss the written fall protection plan with their OSHA area office prior to going on a job site. Statement of company policy. Company name is dedicated to the protection of its employees from on-the-job injuries. All employees of company name have the responsibility to work safely on the job. The purpose of this plan is A. To supplement our standard safety policy by providing safety standards specifically designed to cover fall protection on this job, and B. To ensure that each employee is trained and made aware of the safety provisions which are to be implemented by this plan prior to the start of erection. This fall protection plan addresses the use of other than conventional fall protection at a number of areas on the project, as well as identifying specific activities that require non-conventional means of fall protection. These areas include: at connecting activity, point of erection. B. Leading edge work. C. Unprotected sides or edge. D. Grouting. This plan is designed to enable employers and employees to recognize the fall hazards on this job and to establish the procedures that are to be followed in order to prevent falls to lower levels or through holes and openings in walking/working surfaces. Each employee will be trained in these procedures and strictly adhere to them, except when doing so would expose the employee to a greater hazard. If, in the employee's opinion, this is the case, the employee is to notify the foreman of the concern and the concern addressed before proceeding. Safety policy and procedure on any one project cannot be administered, implemented, monitored, and enforced by any one individual. The total objective of a safe, accident-free work environment can only be accomplished by a dedicated, concerted effort by every individual involved with the project, from management down to the last employee. Each employee must understand their value to the company, the costs of accidents, both monetary, physical, and emotional, the objective of the safety policy and procedures, the safety rules that apply to the safety policy and procedures, and what their individual role is in administering, implementing, monitoring, and compliance of their safety policy and procedures. This allows for a more personal approach to compliance through planning, training, understanding, and cooperative effort, rather than by strict enforcement. If for any reason an unsafe act persists, strict enforcement will be implemented. It is the responsibility of name of competent person to implement this fall protection plan. Name of competent person is responsible for continual observational safety checks of their work operations and to enforce the safety policy and procedures. The foreman also is responsible to correct any unsafe acts or conditions immediately. It is the responsibility of the employee to understand and adhere to the procedures of this plan and to follow the instructions of the foreman. It is also the responsibility of the employee to bring to management's attention any unsafe or hazardous conditions or acts that may cause injury to either themselves or any other employees. Any changes to this fall protection plan must be approved by name of qualified person. 2. Fall protection systems to be used on this project. Where conventional fall protection is infeasible or creates a greater hazard at the leading edge and during initial connecting activity, we plan to do this work using a safety monitoring system and expose only a minimum number of employees for the time necessary to actually accomplish the job. The maximum number of workers to be monitored by one safety monitor is 6. We are designating the following trained employees as designated erectors, and they are permitted to enter the controlled access zones and work without the use of conventional fall protection. Safety monitor, designated erector. The safety monitor shall be identified by wearing an orange hard hat. The designated erectors will be identified by one of the following methods. 1. They will wear a blue-colored armband, or 2. They will wear a blue-colored hard hat, or 3. They will wear a blue-colored vest. Only individuals with the appropriate experience, skills, and training will be authorized as designated erectors. All employees that will be working as designated erectors under the safety monitoring system shall have been trained and instructed in the following areas. 1. Recognition of the fall hazards in the work area, at the leading edge and when making initial connections point of erection. 2. Avoidance of fall hazards using established work practices which have been made known to the employees. 3. Recognition of unsafe practices or working conditions that could lead to a fall, such as windy conditions. 4. The function, use, and operation of safety monitoring systems, guardrail systems, body belt/harness systems, control zones, and other protection to be used. 5. The correct procedure for erecting, maintaining, disassembling, and inspecting the systems to be used. 6. Knowledge of construction sequence or the erection plan. A conference will take place prior to starting work involving all members of the erection crew, crane crew, and supervisors of any other concerned contractors. This conference will be conducted by the precast concrete erection supervisor in charge of the project. During the pre-work conference, erection procedures and sequences pertinent to this job will be thoroughly discussed and safety practices to be used throughout the project will be specified. Further, all personnel will be informed that the controlled access zones are off limits to all personnel other than those designated erectors specifically trained to work in that area. Safety monitoring system. A safety monitoring system means a fall protection system in which a competent person is responsible for recognizing and warning employees of fall hazards. The duties of the safety monitor are to 1. Warn by voice when approaching the open edge in an unsafe manner. 2. Warn by voice if there is a dangerous situation developing which cannot be seen by another person involved with product placement, such as a member getting out of control. 3. Make the designated erectors aware they are in a dangerous area. 4. Be competent in recognizing fall hazards. 5. Warn employees when they appear to be unaware of a fall hazard or are acting in an unsafe manner. 6. Be on the same walking/working surface as the monitored employees and within visual sighting distance of the monitored employees. 7. Be close enough to communicate orally with the employees. 8. Not allow other responsibilities to encumber monitoring. If the safety monitor becomes too encumbered with other responsibilities, the monitor shall 1. Stop the erection process, and 2. Turn over other responsibilities to a designated erector, or 3. Turn over the safety monitoring function to another designated, competent person. The safety monitoring system shall not be used when the wind is strong enough to cause loads with large surface areas to swing out of radius, or result conditions cause the walking working surfaces to become icy, or conditions cause the walking working surfaces to become icy or in loss of control of the load, or when weather slippery. Control zone system. A controlled access zone means an area designated and clearly marked, in which leading edge work may take place without the use of guardrail, safety net, or personal fall arrest systems to protect the employees in the area. Control zone systems shall comply with the following provisions. 1. When used to control access to areas where leading edge and other operations are taking place, the controlled access zone shall be defined by a control line or by any other means that restricts access. When control lines are used, they shall be erected not less than 6 feet, L.8 m, nor more than 60 feet, 18 meters, or half the length of the member being erected, whichever is less, from the leading edge. 2. The control line shall extend along the entire length of the unprotected or leading edge and shall be approximately parallel to the unprotected or leading edge. 3. The control line shall be connected on each side to a guardrail system or wall. 4. Control lines shall consist of ropes, wires, tapes, or equivalent materials, and supporting stanchions as follows. 5. Each line shall be flagged or otherwise clearly marked at not more than 6 foot, 1.8 m intervals with high visibility material. 6. Each line shall be rigged and supported in such a way that its lowest point, including sag, is not less than 39 inches, 1 meter from the walking/working surface, and its highest point is not more than 45 inches, 1.3 meters from the walking/working surface. 7. Each line shall have a minimum breaking strength of 200 pounds, 0.88 kN. Holes. All openings greater than 12 inches. X 12 inches. Will have perimeter guarding or covering. All predetermined holes will have the plywood covers made in the precaster's yard and shipped with the member to the job site. Prior to cutting holes on the job, proper protection for the hole must be provided to protect the workers. Perimeter guarding or covers will not be removed without the approval of the erection foreman. Precast concrete column erection through the existing deck requires that many holes be provided through this deck. These are to be covered and protected. Except for the opening being currently used to erect a column, all opening protection is to be left undisturbed. The opening being uncovered to erect a column will become part of the point of erection and will be addressed as part of this fall protection plan. This uncovering is to be done at the erection foreman's direction and will only occur immediately prior to feeding the column through the opening. Once the end of the column is through the slab opening, there will no longer exist a fall hazard at this location. 3. Implementation of fall protection plan. The structure being erected is a multi-story total precast concrete building consisting of columns, beams, wall panels and hollow core slabs in double T-floor and roof members. The following is a list of the products and erection situations on this job. Columns. For columns 10 feet to 36 feet long, employees disconnecting crane hooks from columns will work from a ladder and wear a body belt/harness with lanyard and be tied off when both hands are needed to disconnect. For tying off, a vertical lifeline will be connected to the lifting eye at the top of the column, prior to lifting, to be used with a manually operated or mobile rope grab. For columns too high for the use of a ladder, 36 feet and higher, an added cable will be used to reduce the height of the disconnecting point so that a ladder can be used. This cable will be left in place until a point in erection that it can be removed safely. In some cases, columns will be unhooked from the crane by using an erection tube or shackle with a pull pin which is released from the ground after the column is stabilized. The column will be adequately connected and/or braced to safely support the weight of a ladder with an employee on it. Inverted T-beams. Employees erecting inverted T-beams at a height of 6 to 40 feet will erect the beam, make initial connections, and final alignment from a ladder. If the employee needs to reach over the side of the beam to bar or make an adjustment to the alignment of the beam, they will mount the beam and be tied off to the lifting device in the beam after ensuring the load has been stabilized on its bearing. To disconnect the crane from the beam, an employee will stand a ladder against the beam. Because the use of ladders is not practical at heights above 40 feet, beams will be initially placed with the use of taglines and their final alignment made by a person on a man lift or similar employee positioning systems. Spandrel beams at the exterior of the building will be aligned as closely as possible with the use of taglines, with the final placement of the spandrel beam made from a ladder at the open end of the structure. A ladder will be used to make the initial connections and a ladder will be used to disconnect the crane. The other end of the beam will be placed by the designated erector from the double T deck under the observation of the safety monitor. The beams will be adequately connected and/or braced to safely support the weight of a ladder with an employee on it. Floor and roof members. During installation of the precast concrete floor and/or roof members, the work deck continuously increases in area as more and more units are being erected and positioned. Thus, the unprotected floor/roof perimeter is constantly modified with the leading edge changing location as each member is installed. The fall protection for workers at the leading edge shall be assured by properly constructed and maintained control zone lines not more than 60 feet away from the leading edge, supplemented by a safety monitoring system to ensure the safety of all designated erectors working within the area defined by the control zone lines. The hollow core slabs erected on the masonry portion of the building will be erected and grouted using the safety monitoring system. Grout will be placed in the space between the end of the slab and face shell of the concrete masonry by dumping from a wheelbarrow. The grout in the keyways between the slabs will be dumped from a wheelbarrow and then spread with long-handled tools, allowing the worker to stand erect facing toward the unprotected edge and back from any workdeck edge. Whenever possible, the designated erectors will approach the incoming member at the leading edge only after it is below waist height so that the member itself provides protection against falls. Except for the situations described below, when the arriving floor or roof member is within 2 to 3 inches of its final position, the designated erectors can then proceed to their position of erection at each end of the member under the control of the safety monitor. Crane hooks will be unhooked from double T members by designated erectors under the direction and supervision of the safety monitor. Designated erectors, while waiting for the next floor or roof member, will be constantly under the control of the safety monitor for fall protection and are directed to stay a minimum of 6 ft from the edge. In the event a designated erector must move from one end of a member, which has just been placed at the leading edge, they must first move away from the leading edge a minimum of 6 feet and then progress to the other end while maintaining the minimum distance of 6 feet at all times. Erection of double Ts, where conditions require bearing of one end into a closed pocket and the other end on a beam ledge, restricting the T legs from going directly into the pockets, require special considerations. The T-legs that are to bear in the closed pocket must hang lower than those at the beam bearing. The double T will be two-lined in order to elevate one end higher than the other to allow for the low end to be ducked into the closed pocket using the following procedure. The double T will be rigged with a standard four-way spreader off of the main load line. An additional choker will be attached to the married point of the two-legged spreader at the end of the T that is to be elevated. The double T will be hoisted with the main load line and swung into a position as close as possible to the T's final bearing elevation. When the T is in this position and stabilized, the whip line load block will be lowered to just above the T deck. At this time, two erectors will walk out on the suspended T deck at mid-span of the T member and pull the load block to the end of the T to be elevated and attach the additional choker to the load block. The possibility of entanglement with the crane lines and other obstacles during this two-lining process while raising and lowering the crane block on that second line could be hazardous to an encumbered employee. Therefore, the designated erectors will not tie off during any part of this process. While the designated erectors are on the double T, the safety monitoring system will be used. After attaching the choker, the two erectors then step back on the previously erected T deck and signal the crane operator to hoist the load with the whip line to the elevation that will allow for enough clearance to let the low-end T-legs slide into the pockets when the main load line is lowered. The erector, who is handling the lowered end of the T at the closed pocket bearing, will step out on the suspended T. An erection bar will then be placed between the end of the T-leg and the inside face of the pocketed spandrel member. The T is barred away from the pocketed member to reduce the friction and lateral force against the pocketed member. As the T is being lowered, the other erector remains on the T, which was previously erected to handle the other end. At this point, the T is slowly lowered by the crane to a point where the T-legs can freely slide into the pockets. The erector working the lowered end of the T must keep pressure on the bar between the T and the face of the pocketed spandrel member to very gradually let the T-leg slide into the pocket to its proper bearing dimension. The T is then slowly lowered into its final erected position. The designated erector should be allowed onto the suspended double T, otherwise there is no control over the horizontal movement of the double T, and this movement could knock the spandrel off of its bearing or the column out of plumb. The control necessary to prevent hitting the spandrel can only be done safely from the top of the double T being erected. Load-bearing wall panels. The erection of the load-bearing wall panels on the elevated decks requires the use of a safety monitor and a controlled access zone that is a minimum of 25 feet and a maximum of 1/2 the length of the wall panels away from the unprotected edge, so that designated erectors can move freely and unencumbered when receiving the panels. Bracing, if required for stability, will be installed by ladder. After the braces are secured, the crane will be disconnected from the wall by using a ladder. The wall-to-wall connections will also be performed from a ladder. Non-load-bearing panels, cladding. The locating of survey lines, panel layout, and other installation prerequisites, pre-welding, etc., for non-load-bearing panels, cladding, will not commence until floor perimeter and floor openings have been protected. In some areas, it is necessary because of panel configuration to remove the perimeter protection as the cladding is being installed. Removal of perimeter protection will be performed on a bay-to-bay basis, just ahead of cladding erection to minimize temporarily unprotected floor edges. Those workers within 6 feet of the edge, receiving and positioning the cladding when the perimeter protection is removed shall be tied off. Detailing. Employees exposed to falls of 6 feet or more to lower levels, who are not actively engaged in leading edge work or connecting activity, such as welding, bolting, cutting, bracing, guying, patching, painting or other operations, and who are working less than 6 feet from an unprotected edge will be tied off at all times or guardrails will be installed. Employees engaged in these activities but who are more than 6 feet from an unprotected edge as defined by the control zone lines do not require fall protection, but a warning line or control lines must be erected to remind employees they are approaching an area where fall protection is required. 4. Conventional fall protection considered for the point of erection or leading edge erection operations. Personal fall arrest systems. In this particular erection sequence and procedure, personal fall arrest systems requiring body belt/harness systems, lifelines and lanyards will not reduce possible hazards to workers and will create offsetting hazards during their usage at the leading edge of precast/pre-stressed concrete construction. Leading-edge erection and initial connections are conducted by employees who are specifically trained to do this type of work and are trained to recognize the fall hazards. The nature of such work normally exposes the employee to the fall hazard for a short period of time, and installation of fall protection systems for a short duration is not feasible because it exposes the installers of the system to the same fall hazard, but for a longer period of time. 1. It is necessary that the employee be able to move freely without encumbrance in order to guide the sections of precast concrete into their final position without having lifelines attached, which will restrict the employee's ability to move about at the point of erection. 2. A typical procedure requires 2 or more workers to maneuver around each other as a concrete member is positioned to fit into the structure. If they are each attached to a lifeline, part of their attention must be diverted from their main task of positioning a member weighing several tons to the task of avoiding entanglements of their lifelines or avoiding tripping over lanyards. Therefore, if these workers are attached to lanyards, more fall potential would result than from not using such a device. In this specific erection sequence and procedure, retractable lifelines do not solve the problem of 2 workers becoming tangled. In fact, such a tangle could prevent the lifeline from retracting as the worker moved, thus potentially exposing the worker to a fall greater than 6 feet. Also, a worker crossing over the lifeline of another worker can create a hazard because the movement of one person can unbalance the other. In the event of a fall by one person, there is a likelihood that the other person will be caused to fall as well. In addition, if contamination such as grout, during hollow core grouting, enters the retractable housing, it can cause excessive wear and damage to the device and could clog the retracting mechanism as the lanyard is dragged across the deck. Obstructing the cable orifice can defeat the device's shock-absorbing function, produce cable slack and damage, and adversely affect cable extraction and retraction. 3. Employees tied to a lifeline can be trapped and crushed by moving structural members if the employee becomes restrained by the lanyard or retractable lifeline and cannot get out of the path of the moving load. The sudden movement of a precast concrete member being raised by a crane can be caused by a number of factors. When this happens, a connector may immediately have to move a considerable distance to avoid injury. If a tied-off body belt/harness is being used, the connector could be trapped. Therefore, there is a greater risk of injury if the connector is tied to the structure for this specific erection sequence and procedure. When necessary to move away from a retractable device, the worker cannot move at a rate greater than the device locking speed, typically 3.5 to 4.5 feet per second. When moving toward the device, it is necessary to move at a rate which does not permit cable slack to build up. This slack may cause cable retraction acceleration and cause a worker to lose their balance by applying a higher than normal jerking force on the body when the cable suddenly becomes taut after building up momentum. This slack can also cause damage to the internal spring-loaded drum, uneven coiling of cable on the drum, and possible cable damage. The factors causing sudden movements for this location include: A. Cranes. 1. Operator error. 2. Site conditions, soft or unstable ground. 3. Mechanical failure. 4. Structural failure. 5. Rigging failure. 6. Crane signal/radio communication failure. B. Weather conditions. 1. Wind, strong wind/sudden gusting, particularly a problem with the large surface areas of precast concrete members. 2. Snow/rain, visibility. 3. Fog, visibility. 4. Cold, causing slowed reactions or mechanical problems. C. Structure/product conditions. 1. Lifting eye failure. 2. Bearing failure or slippage. 3. Structure shifting. 4. Bracing failure. 5. Product failure. D. Human error. 1. Incorrect tagline procedure. 2. Tagline hang-up. 3. Incorrect or misunderstood crane signals. 4. Misjudged elevation of member. 5. Misjudged speed of member. 6. Misjudged angle of member. 4. Anchorages or special attachment points could be cast into the precast concrete members if sufficient pre-planning and consideration of erector's position is done before the members are cast. Any hole or other attachment must be approved by the engineer who designed the member. It is possible that some design restrictions will not allow a member to be weakened by an additional hole. However, it is anticipated that such situations would be the exception, not the rule. Attachment points, other than on the deck surface, will require removal and/or patching. In order to remove and/or patch these points, requires the employee to be exposed to an additional fall hazard at an unprotected perimeter. The fact that attachment points could be available anywhere on the structure does not eliminate the hazards of using these points for tying off as discussed above. A logical point for tying off on double T's would be using the lifting loops, except that they must be cut off to eliminate a tripping hazard at an appropriate time. 5. Providing attachment at a point above the walking/working surface would also create fall exposures for employees installing their devices. Final positioning of a precast concrete member requires it to be moved in such a way that it must pass through the area that would be occupied by the lifeline and the lanyards attached to the point above. Resulting entanglements of lifelines and lanyards on a moving member could pull employees from the work surface. Also, the structure is being created and, in most cases, there is no structure above the members being placed. A. Temporary structural supports, installed to provide attaching points for lifelines, limit the space which is essential for orderly positioning, alignment and placement of the precast concrete members. To keep the lanyards a reasonable and manageable length, lifeline supports would necessarily need to be in proximity to the positioning process. A sudden shift of the precast concrete member being positioned because of wind pressure or crane movement could make it strike the temporary supporting structure, moving it suddenly and causing tied-off employees to fall. B. The time and man-hours which would be expended in placing and maintaining temporary structural supports for lifeline attaching points could exceed the expended man-hours involved in placing the precast concrete members. No protection could be provided for the employees erecting the temporary structural supports, and these supports would have to be moved for each successive step in the construction process, thus greatly increasing the employee's exposure to the fall hazard. C. The use of a cable strung horizontally between two columns to provide tie-off lines for erecting or walking a beam for connecting work is not feasible and creates a greater hazard on this multi-story building for the following reasons. 1. If a connector is to use such a line, it must be installed between the two columns. To perform this installation requires an erector to have more fall exposure time attaching the cable to the columns than would be spent to make the beam-to-column connection itself. 2. If such a line is to be installed so that an erector can walk along a beam, it must be overhead or below him. For example, if a connector must walk along a 24 inches wide beam, the presence of a line next to the connector at waist level, attached directly to the columns, would prevent the connector from centering their weight over the beam and balancing themselves. Installing the line above the connector might be possible on the first level of a two-story column. However, the column may extend only a few feet above the floor level at the second level or be flush with the floor level. Attaching the line to the side of the beam could be a solution, however, it would require the connector to attach the lanyard below foot level, which would most likely extend a fall farther than 6 feet. 3. When lines are strung over every beam, it becomes more and more difficult for the crane operator to lower a precast concrete member into position without the member becoming fouled. Should the member become entangled, it could easily dislodge the line from a column. If a worker is tied to it at the time, a fall could be caused. 6. The ANSI A10.14-1991 American National Standard for Construction and Demolition Operations requirements for safety belts, harnesses, lanyards and lifelines for construction and demolition use, states that the anchor point of a lanyard or deceleration device should, if possible, be located above the wearer's belt or harness attachment. ANSI A10.14 also states that a suitable anchorage point is one which is located as high as possible to prevent contact with an obstruction below should the worker fall. Most manufacturers also warn in the user's handbook that the safety block/retractable lifeline must be positioned above the D-ring, above the workspace of the intended user, and OSHA recommends that fall arrest and restraint equipment be used in accordance with the manufacturer's instructions. Attachment of a retractable device to a horizontal cable near floor level or using the inserts in the floor or roof members may result in increased free fall due to the dorsal D-ring of the full-body harness riding higher than the attachment point of the snap hook to the cable or insert. E.g., 6-foot-tall worker with a dorsal D-ring at 5 feet above the floor or surface reduces the working length to only 1 foot by placing the anchorage 5 feet away from the fall hazard. In addition, impact loads may exceed maximum fall arrest forces, MAF, because the fall arrest steering would be 4 to 5 feet higher than the safety block/retractable lifeline anchored to the walking working surface, and the potential for swing hazards is increased. Manufacturers also require that workers not work at a level where the point of snap hook attachment to the body harness is above the device, because this will increase the free fall distance and the deceleration distance and will cause higher forces on the body in the event of an accidental fall. Manufacturers recommend an anchorage for the retractable lifeline which is immovably fixed in space and is independent of the user's support systems. A movable anchorage is one which can be moved around, such as equipment or wheeled vehicles, or which can deflect substantially under shock loading, such as a horizontal cable or very flexible beam. In the case of a very flexible anchorage, a shock load applied to the anchorage during fall arrest can cause oscillation of the flexible anchorage such that the retractable brake mechanism may undergo one or more cycles of locking/unlocking/locking, ratchet effect, until the anchorage deflection is dampened. Therefore, use of a movable anchorage involves critical engineering and safety factors and should only be considered after fixed anchorage has been determined to be not feasible. Horizontal cables used as an anchorage present an additional hazard due to amplification of the horizontal component of maximum arrest force of a fall, transmitted to the points where the horizontal cable is attached to the structure. This amplification is due to the angle of sag of a horizontal cable and is most severe for small angles of sag. For a cable sag angle of 2 degrees, the horizontal force on the points of cable attachment can be amplified by a factor of 15. It is also necessary to install the retractable device vertically overhead to minimize swing falls. If an object is in the worker's swing path, or that of the cable, hazardous situations exist. 1. Due to the swing, horizontal speed of the user may be high enough to cause injury when an obstacle in the swing fall path is struck by either the user or the cable. 2. The total vertical fall distance of the user may be much greater than if the user had fallen only vertically without a swing fall path. With retractable lines, overconfidence may cause the worker to engage in inappropriate behavior, such as approaching the perimeter of a floor or roof at a distance appreciably greater than the shortest distance between the anchorage point and the leading edge. Though the retractable lifeline may arrest a worker's fall before he or she has fallen a few feet, the lifeline may drag along the edge of the floor or beam and swing the worker like a pendulum until the line has moved to a position where the distance between the anchorage point and floor edge is the shortest distance between those 2 points. Accompanying this pendulum swing is a lowering of the worker, with the attendant danger that he or she may violently impact the floor or some obstruction below. The risk of a cable breaking is increased if a lifeline is dragged sideways across the rough surface or edge of a concrete member at the same moment that the lifeline is being subjected to a maximum impact loading during a fall. The typical 3/16 inch cable in a retractable lifeline has a breaking strength of from 3,000 to 3,700 pounds. 7. The competent person, who can take into account the specialized operations being performed on this project, should determine when and where a designated erector cannot use a personal fall arrest system. B. Safety net systems. The nature of this particular precast concrete erection worksite precludes the safe use of safety nets where point of erection or leading edge work must take place. To install safety nets in the interior high bay of the single-story portion of the building poses rigging attachment problems. Structural members do not exist to which supporting devices for nets can be attached in the area where protection is required. As the erection operation advances, the location of point of erection or leading edge work changes constantly as each member is attached to the structure. Due to this constant change, it is not feasible to set net sections and build separate structures to support the nets. 2. The nature of the erection process for the precast concrete members is such that an installed net would protect workers as they position and secure only one structural member. After each member is stabilized, the net would have to be moved to a new location. This could mean a move of 8 to 10 feet or the possibility of a move to a different level or area of the structure, to protect workers placing the next piece in the construction sequence. The result would be the installation and dismantling of safety nets repeatedly throughout the normal workday. As the time necessary to install a net, test, and remove it is significantly greater than the time necessary to position and secure a precast concrete member, the exposure time for the worker installing the safety net would be far longer than for the workers whom the net is intended to protect. The time exposure repeats itself each time. The nets and supporting hardware must be moved laterally or upward to provide protection at the point of erection or leading edge. 3. Strict interpretation of 1926.502(c) requires that operation shall not be undertaken until the net is in place and has been tested. With the point of erection constantly changing, the time necessary to install and test a safety net significantly exceeds the time necessary to position and secure the concrete member. 4. Use of safety nets on exposed perimeter wall openings and open-sided floors causes attachment points to be left in architectural concrete, which must be patched and filled with matching material after the net supporting hardware is removed. In order to patch these openings, additional numbers of employees must be suspended by swing stages, bosun chairs, or other devices, thereby increasing the amount of fall exposure time to employees. 5. Installed safety nets pose an additional hazard at the perimeter of the erected structure where limited space is available in which members can be turned after being lifted from the ground by the crane. There would be a high probability that the member being lifted could become entangled in net hardware, cables, etc. 6. The use of safety nets where structural wall panels are being erected would prevent movement of panels to point of installation. To be effective, nets would necessarily have to provide protection across the area where structural supporting wall panels would be set and plumbed before roof units could be placed. 7. Use of a tower crane for the erection of the high-rise portion of the structure poses a particular hazard in that the crane operator cannot see or judge the proximity of the load in relation to the structure or nets. If the signaler is looking through nets and supporting structural devices while giving instructions to the crane operator, it is not possible to judge precise relationships between the load and the structure itself or to nets and supporting structural devices. This could cause the load to become entangled in the net or hit the structure, causing potential damage. C. Guardrail systems. On this particular worksite, guardrails, barricades, ropes, cables, or other perimeter guarding devices or methods on the erection floor will pose problems to safe erection procedures. Typically, a floor or roof is erected by placing 4 to 10 feet wide structural members next to one another and welding or grouting them together. The perimeter of a floor and roof changes each time a new member is placed into position. It is unreasonable and virtually impossible to erect guardrails and toe boards at the ever-changing leading edge of a floor or roof. 1. To position a member safely, it is necessary to remove all obstructions extending above the floor level near the point of erection. Such a procedure allows workers to swing a new member across the erected surface as necessary to position it properly without worrying about knocking material off of this surface. Hollow core slab erection on the masonry wall requires installation of the perimeter protection where the masonry wall has to be constructed. This means the guardrail is installed then subsequently removed to continue the masonry construction. The erector will be exposed to a fall hazard for a longer period of time while installing and removing perimeter protection than while erecting the slabs. In hollow core work, as in other precast concrete erection, others are not typically on the work deck until the precast concrete erection is complete. The deck is not complete until the leveling, aligning, and grouting of the joints is done. It is normal practice to keep others off the deck until at least the next day after the installation is complete to allow the grout to harden. 2. There is no permanent boundary until all structural members have been placed in the floor or roof. At the leading edge, workers are operating at the temporary edge of the structure as they work to position the next member in the sequence. Compliance with the standard would require a guardrail and toe board be installed along this edge. However, the presence of such a device would prevent a new member from being swung over the erected surface low enough to allow workers to control it safely during the positioning process. Further, these employees would have to work through the guardrail to align the new member and connect it to the structure. The guardrail would not protect an employee who must lean through it to do the necessary work, rather it would hinder the employee to such a degree that a greater hazard is created than if the guardrail were absent. 3. Guardrail requirements pose a hazard at the leading edge of installed floor or roof sections by creating the possibility of employees being caught between guardrails and suspended loads. The lack of a clear work area in which to guide the suspended load into position for placement and welding of members into the existing structure creates still further hazards. For where erection processes require precast concrete stairways or openings to be installed as an integral part of the overall erection process, it must also be recognized that guardrails or handrails must not project above the surface of the erection floor. Such guardrails should be terminated at the level of the erection floor to avoid placing hazardous obstacles in the path of a member being positioned. Other fall protection measures considered for this job. The following is a list and explanation of other fall protection measures available and an explanation of limitations for use on this particular job site. If during the course of erecting the building the employee sees an area that could be erected more safely by the use of these fall protection measures, the foreman should be notified. A. Scaffolds are not used because 1. The leading edge of the building is constantly changing and the scaffolding would have to be moved at very frequent intervals. Employees erecting and dismantling the scaffolding would be exposed to fall hazards for a greater length of time than they would by merely erecting the precast concrete member. 2. A scaffold tower could interfere with the safe swinging of a load by the crane. 3. Power lines, terrain and site do not allow for the safe use of scaffolding. B. Vehicle-mounted platforms are not used because 1. A vehicle-mounted platform will not reach areas on the deck that are erected over other levels. 2. The leading edge of the building is usually over a lower level of the building and this lower level will not support the weight of a vehicle-mounted platform. 3. A vehicle-mounted platform could interfere with the safe swinging of a load by the crane, either by the crane swinging the load over or into the equipment. 4. Power lines and surrounding site work do not allow for the safe use of a vehicle-mounted platform. C. Crane suspended personnel platforms are not used because 1. A second crane close enough to suspend any employee in the working and erecting area could interfere with the safe swinging of a load by the crane hoisting the product to be erected. 2. Power lines and surrounding site work do not allow for the safe use of a second crane on the job. 6. Enforcement. Constant awareness of and respect for fall hazards, and compliance with all safety rules are considered conditions of employment. The job site superintendent, as well as individuals in the Safety and Personnel Department, reserve the right to issue disciplinary warnings to employees, up to and including termination, for failure to follow the guidelines of this program. 7. Accident investigations. All accidents that result in injury to workers, regardless of their nature, shall be investigated and reported. It is an integral part of any safety program that documentation take place as soon as possible so that the cause and means of prevention can be identified to prevent a reoccurrence. In the event that an employee falls or there is some other related, serious incident occurring, this plan shall be reviewed to determine if additional practices, procedures, or training need to be implemented to prevent similar types of falls or incidents from occurring. 8. Changes to plan. Any changes to the plan will be approved by name of the qualified person. This plan shall be reviewed by a qualified person as the job progresses to determine if additional practices, procedures, or training needs to be implemented by the competent person to improve or provide additional fall protection. Workers shall be notified and trained, if necessary, in the new procedures. A copy of this plan and all approved changes shall be maintained at the job site. Sample Fall Protection Plan for Residential Construction, insert company name. This fall protection plan is specific for the following project: location of job, date planned prepared or modified, plan prepared by, plan approved by, plan supervised by. The following fall protection plan is a sample program prepared for the prevention of injuries associated with falls. A fall protection plan must be developed and evaluated on a site-by-site basis. It is recommended that builders discuss the written fall protection plan with their OSHA area office prior to going on a job site. Statement of company policy. Your company name here is dedicated to the protection of its employees from on-the-job injuries. All employees of your company name here have the responsibility to work safely on the job. The purpose of the plan is to supplement our existing safety and health program and to ensure that every employee who works for your company name here recognizes workplace fall hazards and takes the appropriate measures to address those hazards. This fall protection plan addresses the use of conventional fall protection at a number of areas on the project, as well as identifies specific activities that require non-conventional means of fall protection. During the construction of residential buildings under 48 feet in height, it is sometimes infeasible or it creates a greater hazard to use conventional fall protection systems at specific areas or for specific tasks. The areas or tasks may include, but are not limited to, a. Setting and bracing of roof trusses and rafters. B. Installation of floor sheathing and joists. C. Roof sheathing operations. And D. Erecting exterior walls. In these cases, conventional fall protection systems may not be the safest choice for builders. This plan is designed to enable employers and employees to recognize the fall hazards associated with this job and to establish the safest procedures that are to be followed in order to prevent falls to lower levels or through holes and openings in walking/working surfaces. Each employee will be trained in these procedures and will strictly adhere to them except when doing so would expose the employee to a greater hazard. If, in the employee's opinion, this is the case, the employee is to notify the competent person of their concern and have the concern addressed before proceeding. It is the responsibility of, name of competent person, to implement this fall protection plan. Continual observational safety checks of work operations and the enforcement of the safety policy and procedures shall be regularly enforced. The crew supervisor or foreman, insert name, is responsible for correcting any unsafe practices or conditions immediately. It is the responsibility of the employer to ensure that all employees understand and adhere to the procedures of this plan and to follow the instructions of the crew supervisor. It is also the responsibility of the employee to bring to management's attention any unsafe or hazardous conditions or practices that may cause injury to either themselves or any other employees. Any changes to the fall protection plan must be approved by name of qualified person. 2. Fall protection systems to be used on this job. Installation of roof trusses/rafters, exterior wall erection, roof sheathing, floor sheathing and joist/truss activities will be conducted by employees who are specifically trained to do this type of work and are trained to recognize the fall hazards. The nature of such work normally exposes the employee to the fall hazard for a short period of time. This plan details how, your company name here, will minimize these hazards. Controlled access zones. When using the plan to implement the fall protection options available, workers must be protected through limited access to high-hazard locations. Before any non-conventional fall protection systems are used as part of the work plan, a controlled access zone, CAZ, shall be clearly defined by the competent person as an area where a recognized hazard exists. The demarcation of the CAZ shall be communicated by the competent person in a recognized manner, either through signs, wires, tapes, ropes or chains. Your company name here shall take the following steps to ensure that the CAZ is clearly marked or controlled by the competent person. All access to the CAZ must be restricted to authorized entrance. All workers who are permitted in the CAZ shall be listed in the appropriate sections of the plan, or be visibly identifiable by the competent person, prior to implementation. The competent person shall ensure that all protective elements of the CAZ be implemented prior to the beginning of work. Installation procedures for roof truss and rafter erection. During the erection and bracing of roof trusses/rafters, conventional fall protection may present a greater hazard to workers. On this job, safety nets, guardrails and personal fall arrest systems will not provide adequate fall protection because the nets will cause the walls to collapse, while there are no suitable attachment or anchorage points for guardrails or personal fall arrest systems. On this job, requiring workers to use a ladder for the entire installation process will cause a greater hazard because the worker must stand on the ladder with his back or side to the front of the ladder. While erecting the truss or rafter, the worker will need both hands to maneuver the truss and therefore cannot hold onto the ladder. In addition, ladders cannot be adequately protected from movement while trusses are being maneuvered into place. Many workers may experience additional fatigue because of the increase in overhead work with heavy materials, which can also lead to a greater hazard. Exterior scaffolds cannot be utilized on this job because the ground, after recent backfilling, cannot support the scaffolding. In most cases, the erection and dismantling of the scaffold would expose workers to a greater fall hazard than erection of the trusses/rafters. On all walls 8 feet or less, workers will install interior scaffolds along the interior wall below the location where the trusses/rafters will be erected. Sawhorse scaffolds constructed of 46-inch sawhorses and 2x10 planks will often allow workers to be elevated high enough to allow for the erection of trusses and rafters without working on the top plate of the wall. In structures that have walls higher than 8 feet and where the use of scaffolds and ladders would create a greater hazard, safe working procedures will be utilized when working on the top plate and will be monitored by the crew supervisor. During all stages of truss/rafter erection, the stability of the trusses/rafters will be ensured at all times. Your company name here shall take the following steps to protect workers who are exposed to fall hazards while working from the top plate installing trusses/rafters. Only the following trained workers will be allowed to work on the top plate during roof truss or rafter installation. Workers shall have no other duties to perform during truss/rafter erection procedures. All trusses/rafters will be adequately braced before any worker can use the truss/rafter as a support. Workers will remain on the top plate using the previously stabilized truss/rafter as a support while other trusses/rafters are being erected. Workers will leave the area of the secured trusses only when it is necessary to secure another truss/rafter. The first two trusses/rafters will be set from ladders leaning on side walls at points where the walls can support the weight of the ladder. And a worker will climb onto the interior top plate via a ladder to secure the peaks of the first two trusses/rafters being set. The workers responsible for detaching trusses from cranes and or securing trusses at the peaks traditionally are positioned at the peak of the trusses/rafters. There are also situations where workers securing rafters to ridge beams will be positioned on top of the ridge beam. Your company name here shall take the following steps to protect workers who are exposed to fall hazards while securing trusses/rafters at the peak of the trusses/ridge beam. Only the following trained workers will be allowed to work at the peak during roof truss or rafter installation. Once truss or rafter installation begins, workers not involved in that activity shall not stand or walk below or adjacent to the roof opening or exterior walls in any area where they could be struck by falling objects. Workers shall have no other duties than securing/bracing the trusses/ridge beam. Workers positioned at the peaks or in the webs of trusses or on top of the ridge beam shall work from a stable position, either by sitting on a ridge seat or other equivalent surface that provides additional stability, or by positioning themselves in previously stabilized trusses/rafters and leaning into and reaching through the trusses/rafters. Workers shall not remain on or in the peak/ridge any longer than necessary to safely complete the task. Roof sheathing operations. Workers typically install roof sheathing after all trusses/rafters and any permanent truss bracing is in place. Roof structures are unstable until some sheathing is installed, so workers installing roof sheathing cannot be protected from fall hazards by conventional fall protection systems until it is determined that the roofing system can be used as an anchorage point. At that point, employees shall be protected by a personal fall arrest system. Trusses/rafters are subject to collapse if a worker falls while attached to a single truss with a belt/harness. Nets could also cause collapse, and there is no place to attach guardrails. All workers will ensure that they have secure footing before they attempt to walk on the sheathing, including cleaning shoes/boots of mud or other slip hazards. To minimize the time workers must be exposed to a fall hazard, materials will be staged to allow for the quickest installation of sheathing. Your company name here shall take the following steps to protect workers who are exposed to fall hazards while installing roof sheathing. Once roof sheathing installation begins, workers not involved in that activity shall not stand or walk below or adjacent to the roof opening or exterior walls in any area where they could be struck by falling objects. The competent person shall determine the limits of this area, which shall be clearly communicated to workers prior to placement of the first piece of roof sheathing. The competent person may order work on the roof to be suspended for brief periods as necessary to allow other workers to pass through such areas when this would not create a greater hazard. Only qualified workers shall install roof sheathing. The bottom row of roof sheathing may be installed by workers standing in truss webs. After the bottom row of roof sheathing is installed, a slide guard extending the width of the roof shall be securely attached to the roof. Slide guards are to be constructed of no less than nominal 4-inch height capable of limiting the uncontrolled slide of workers. Workers should install the slide guard while standing in truss webs and leaning over the sheathing. Additional rows of roof sheathing may be installed by workers positioned on previously installed rows of sheathing. A slide guard can be used to assist workers in retaining their footing during successive sheathing operations, and additional slide guards shall be securely attached to the roof at intervals not to exceed 13 feet as successive rows of sheathing are installed. For roofs with pitches in excess of 9 and 12, slide guards will be installed at 4-foot intervals. When wet weather, rain, snow, or sleet are present, roof sheathing operations shall be suspended unless safe footing can be assured for those workers installing sheathing. When strong winds, above 40 miles per hour, are present, roof sheathing operations are to be suspended unless windbreakers are erected. Installation of floor joists and sheathing. During the installation of floor sheathing/joists, leading edge construction, the following steps shall be taken to protect workers. Only the following trained workers will be allowed to install floor joists or sheathing. Materials for the operation shall be conveniently staged to allow for easy access to workers. The first floor joists or trusses will be rolled into position and secured either from the ground, ladders, or sawhorse scaffolds. Each successive floor joist or truss will be rolled into place and secured from a platform created from a sheet of plywood laid over the previously secured floor joists or trusses. Except for the first row of sheathing, which will be installed from ladders or the ground, workers shall work from the established deck. And any workers not assisting in the leading edge construction while leading edges still exist, e.g., cutting the decking for the installers, shall not be permitted within 6 feet of the leading edge under construction. Erection of exterior walls. During the construction and erection of exterior walls, employers shall take the following steps to protect workers. Only the following trained workers will be allowed to erect exterior walls. A painted line 6 feet from the perimeter will be clearly marked prior to any wall erection activities to warn of the approaching unprotected edge. Materials for operations shall be conveniently staged to minimize fall hazards. And workers constructing exterior walls shall complete as much cutting of materials and other preparation as possible away from the edge of the deck. 3. Enforcement. Constant awareness of and respect for fall hazards, and compliance with all safety rules are considered conditions of employment. The crew supervisor or foreman, as well as individuals in the Safety and Personnel Department, reserve the right to issue disciplinary warnings to employees, up to and including termination, for failure to follow the guidelines of this program. 4. Accident investigations. All accidents that result in injury to workers, regardless of their nature, shall be investigated and reported. It is an integral part of any safety program that documentation take place as soon as possible so that the cause and means of prevention can be identified to prevent a reoccurrence. In the event that an employee falls or there is some other related, serious incident occurring, this plan shall be reviewed to determine if additional practices, procedures, or training need to be implemented to prevent similar types of falls or incidents from occurring. Via changes to plan. Any changes to the plan will be approved by name of the qualified person. This plan shall be reviewed by a qualified person as the job progresses to determine if additional practices, procedures, or training needs to be implemented by the competent person to improve or provide additional fall protection. Workers shall be notified and trained, if necessary, in the new procedures. A copy of this plan and all approved changes shall be maintained at the job site.